Okay, welcome to the video where we're going to be having a look through all of the topics that have not yet appeared on papers 1 and 2. Now obviously, just like before, the topics that have appeared, just because they've appeared on paper 1 and 2, it doesn't mean that they cannot appear on paper 3. So bear that in mind and make sure that you still have an awareness of some of these topics. That being said, there are particular topics that are very unlikely to then appear again. So for example, scatter graphs that appeared on paper 1, it's very unlikely that that would appear on paper 3 when there's still pie charts, box plots, stem and leaf, and group frequency tables that could appear again. So just because a topic has appeared, don't neglect it in your revision, but obviously the ones that have not yet appeared, they're the ones that we're going to prioritise and we're going to have a look through in this video. So throughout the video, this should give you a pretty good understanding of some of the topics that have appeared and maybe some focus points for you to go and revise. So for example, at one point in this video, we're going to have a look at a graphical inequality. Now if you're not sure what that question's about, that would be a topic for you to go and revise. So use this video wisely and make sure that you obviously practice the topics that you're not 100% on that we do cover here, because they are more than likely to come up. Obviously not all of them are going to come up because they can only test so many, but there are tons of topics here that should give you a good overview of loads of stuff that hasn't yet come up. Obviously we have a lot to get through, so with that being said, let's get started. Okay, so there are 15 pencils in a pack and 40 pens in a box. How many packs of pencils and boxes of pens would we need to buy to have the same amount of each? So we're looking at lowest common multiple, so 15 and 40. I'm going to do a list of their times tables, so 15, 30, 45, 60, 75, 90, 105, 120. And there it is, I know that 40, 80, 120, that's going to be our lowest common multiple there. So the question said how many packs of each, so that is one on the top. We've got 1, 2, 3, 4, 5, 6, 7, 8. That was the pencils, so that's 8 packs of pencils. 8 packs of pencils, and below there we have 1, 2, 3, 3 boxes of pens. Okay, so just remember to read the question there, what's it actually asking for in the final step, even though we were looking at lowest common multiple for that one. Let's have a look at the next one. So find the highest common factor of 72 and 90. So we've got different methods of doing this. We can write down 72, we can write down 90 and start finding all their factors. We can of course use the prime factor method, but let's have a look. Let's start with 90. 1 and 90, 2 and 45, 3 and 30. Let's see what else goes in. 4 doesn't go in, 5 does. 5 goes in 18 times. 6 goes in, let's have a think, 15 times. 7 does and 8 doesn't, 9 does, 9 and 10, now the numbers are right next to each other, so there's no more to look at. So starting with the biggest, let's have a look which one goes in. 90 doesn't, 45 doesn't, 30 doesn't go into 72, does 18. 18 actually goes in 4 times. So 4 times 18, we don't have to do all the factors of 72 there because we've spotted that it's 18. Of course we could use the prime factor method to find the highest common factor, which I'd recommend for numbers like this, so 72 and 90. Do their prime factors, so 8 and 9, 3 and 3, 2 and 4, 2 and 2. 90 is 9 and 10. And then we have 3, 3, 2 and 5. And we can have a look at what's in both. So they both have a 2. They both have a 3, so times 3. They both have another 3. And that's all that they share. 2 times 3 is 6, times 3 again is 18. So we can get our highest common factor using our prime factor method as well. So £800 is invested for 2 years, offering a 1.5% simple interest rate per annum per year. How much is in the account after 2 years? Now, simple interest means it doesn't keep accumulating. So if we first work out what 1.5% is, again, if you haven't got a calculator, we can do this non-calculator. So 10% of 800 would be 80. 1% would therefore be 8, and 0.5%, which we're going to need there, is 4. So joining those two together, the 1 and the 1.5 gives us 12. So we get £12 there for our 1.5%. Now we can do this using a calculator as well, which I'll discuss in a sec, but if we're going to get £12 per year, simple interest just means that's what we're going to get per year. So if it's 2 years, we'll times that by 2 and we will get £24. So that's the amount of interest we'll earn. It does say how much is in the account though, so if we add that back into the account, we'd have £824 as our final answer. Now if you've got a calculator here, you can always use your multiplier method. So we could do 800 and we could times it by 1.015 and that gives us the answer 812, telling us that in that first year there we've earned £12 interest. So adding in another 12, so add another 12 would give us 824, the same answer. Okay, or you could times it by 0.015 and that would have just straight up given you the 12, and you can add that on for how many years for simple interest. So Mary buys a car for £4,000. Each year it depreciates by 20%. Work out the value of the car in 3 years. So that word depreciate means it falls in value. Now again with depreciation, it's similar to compound interest. It falls in value, but it falls in value based on its new price. So if we do this without a calculator, we can do it both ways. Year 1, the £4,000 is what it's worth. 20% of that we can work out. 10% is 400, 20% is 800. And if we take away that 800 there, so 4,000, take away 800, we end up with 3,200. So we don't keep losing £800 a year. Now in the second year, it's worth 3,200. 10% of that is 320. 20% of that is double that, 640. And we could subtract 640. So 3,200 take away 640. Will leave us with our answer for the final year. Take away 640 there, gives us 2,560. And we can finish this off, or I should have said year 2, we can finish this off on year 3. So our value is 2,560. 10% of that is 256. So 20% will be 512, and then we can subtract 512, so 2,560 take away 512 leaves us with a final value there of 2,048. £2,048, and that'd be our final answer. Again, we could do this with a calculator. If something loses 20% in value, then it's only actually worth 80% of its cost the previous year. So if it's worth 80%, the decimal that I can use for 80% is 0.8. If it's losing value, we won't want a 1 point number there, we've got 0.8. So we could just times it by 0.8 3 times, or times it by 0.8 to the power of 3. So I could just type into my calculator 4,000 times 0.8 to the power of 3, and I'll get that answer there, 2,048 as my final answer. And let's test that out. 4,000 times 0.8 to the power of 3, and we get 2,048. So that's depreciation. So in a bag of counters, 2/5 are blue, and it says 18 are blue. Work out the total number of counters in the bag. So it's not asking us to work out 2/5 of a number, it's saying that 2/5 are 18. Remember, it could have said work out 2/5 of, let's say, 20, and you divide by the bottom to get 1/5, you'd say that 1/5 is 4, and then times by the top to get 2/5, and we'd get 2/5 would be 8. That's a different question, so it's nothing to do with that, but it says 2/5 are blue and 18 are blue, so 2/5 equals 18. So if I want to work out 1/5 in this scenario, I need to divide by the top this time, because that gives me 1/5, half of that, so 1/5 would be 9. And then to work out 5/5, the original amount, we could times that by 5. So times it by 5, and we would get 5/5 equaling 45 counters. There you go, so that's our scenario there. So slightly different the other way around, obviously, to working out a fraction of an amount. It says that that fraction is 18. So dividing it by 2 to get 1/5, and then timesing it by 5 to get the original amount. Okay, so writing some numbers in standard form. We're going to make this a number between 1 and 10, times 10 to the power of however many jumps we have to do in whatever particular direction. So this number here, 5,600, I'm going to hop the decimal in between the 5 and the 6. So 1, 2, 3. So that becomes 5.6 times 10 to the power of, it's a big number there, it's not a 0-point number, so 10 to the power of 3. Final answer. The next one is a small number, so we're going to have a negative power, because we hop the decimal the other way this time. So 1, 2, 3. would make it 3.4, and again this time it would be times 10 to the negative 3, because it's a 0 point number. That indicates that it's a small number. When it comes to the other way round, writing them as ordinary numbers, I like to rewrite this little bit at the start to start with. So 2 and 3, and I like to just imagine where that decimal is between the 2 and the 3. So times 10 to the power 5 makes it a big number, so we need to hop it 5 places. 1, 2, 3, 4, 5 to the right, and then filling in all those zeros underneath. And if it is messy, just remember to rewrite that. But there's my answer, 230,000. The next one, 8.04 times 10 to the negative 3. So this is going to be a 0 point number. And again, I'm just going to write these digits out at the start, these bits here, and imagine where the decimal is at the top, 8.04. So negative 3 means it's going to be a small number, so we're going to jump it left 3. 1, 1, 2, 3. So it's going to go there. Fill in all the zeros and tidy it up at the start. So 0.00804, final answer. Okay, so recurring decimals as fractions. So a little rule, we are going to use a bit of algebra for this. But if there's 2 recurring decimals, we're going to times it by 100. And if there's 1 recurring decimal, we times it by 10 and so on. There's lots of different ways of doing this. This is just the way that I do them. So I write what the decimal is. So we've got x equals 0.54. And remember, if there's a dot above the 5 and the 4, that means that that decimal there is 0.5454 and continues like that. It's the 54 that's recurring. It's always good just to write that down, just to remind yourself what that decimal actually represents. So if we've got 2 recurring decimals, we can times that by 100. You'll see why if you've not seen this before. Hopefully it's just a reminder. You get 54.54. Now we can take them away from each other, and that'll eliminate these recurring decimals here. If we take them away from each other, we have 99x's equals 54. And make sure that you actually do use your algebra to show this. Now we can divide both sides by 99. So x equals 54 over 99. And there it is as a fraction. You do just need to check just to see if your fraction simplifies. So do check to see if this one simplifies. This one actually does. The top and the bottom both divide by 9. And you'd normally be asked to show that it equals this next one. But if it doesn't, you know, you can look to simplify if it says to give it in its simplest form. And if you divide them both by 9, you get 6 over 11. So the question might have said show that it equals 6 over 11. And that's how you would show it. You'd show how it simplifies. Now on to the one below. It's only got 1 recurring decimal, but it's a bit of a nasty one. So if we think about what this decimal actually looks like, 0.23 with the dot above the 3, that's 0.2 and then a recurring set of 3s. It's not a full repeating pattern of 2, 3, 2, 3, 2, 3. So if we have a look at this one, and again there are different ways of doing this type of question here, but this is I just follow the same process for all of them. So x equals 0.23 with a dot above the 3, and there's 1 recurring decimal, so let's times it by 10. So we get 10x equals 2.33, and then the 3 keeps going. I'll just balance it out so there's the same amount of decimal places in both. Now if we take these away from each other, something kind of interesting happens here. We get 9x equals, and 2.33 take away 0.23 is 2.1. Now if we take the same approach as before and turn that into a fraction, so dividing both sides by 9, we get x equals 2.1 over 9. And obviously you can't have decimals in fractions, so we need to remove this decimal from the top, so we can times the top and bottom by 10. And that would give us 21 over 90. There you go, and there's your fraction. And again, you just need to check to make sure to see if that simplifies or not. And it actually does. The top and bottom both divide by 3. So you can divide the top and bottom by 3, and you would get 7 over 30. Again, so it might have said show that this fraction equals 7 over 30. But always just check at the end to see if it simplifies. Obviously, if it just said to write it as a fraction, 21 over 90 would be fine. But if it said to give it its simplest form, we would have to look to simplify there. Okay, so some compound interest. James invests £2,500 for 3 years in a savings account and gets 3% per annum compound interest in the first year, and then X% for 2 years. He has this much at the end of the 3 years. Work out the value of X. Well, just like normal compound interest here, we can actually do the first year. So we can work out, I'm just going to label this up. So after the first year, let's see how much money he has. So 2,500 for 3%, we would times that by 1.03. Obviously we don't need to add any powers into there because it is just the first year that he's getting this. So if we do this on the calculator times 1.03, and we get an answer of £2,575. Now we've got a bit of a reverse compound interest scenario, and we're going to have to create a little formula for this, because in the second and third year he gets X%. Now his starting number, and let's just write down second and third, His starting number now is 2,575. Now if we knew the percentage, we'd multiply it by that percentage, which we'll call x in this scenario because we don't know what it is, and we'd do that to the power of 2 as it's 2 years. And what it's saying in the question is that gives us the answer £2,705.36. Obviously at this point here we could just guess some numbers, we could just guess an x value, and if it's too high go lower, if it's too low go higher, and that's a fine way of doing it as well. But you can save yourself a bit of time here just guessing lots of numbers by actually just rearranging this, so we can divide both sides by 2,575 and it will give us the value of x squared. So x squared is going to equal, and again let's just do this on the calculator, 2705.36 divided by that gives us this answer here, 1.050625243. That's obviously the value of x squared, so we need to square root both sides. So if we square root that answer, we get the answer 1.025000118. So that gives us our little percentage here. So it's hidden within this decimal. Now our actual percentage here is not 1.025 because that 1 point is what we increase by for the percentage. So it's just this 0.25 that we're interested in, and 0.25, if you think back to what we did at the start here with 0.3 being 3%, well 0.25 would be 2.5%. There we go, so that's 2.5%, so just be careful that you do read that off there and don't put 1.025 in this type of question. But again, you could have guessed, if you'd have guessed 1.02, it's normally going to be lower than that first one. That's normally what banks do, they give you a better one in the first year and then not so good following that. Okay, so there's just two ways that you can approach that. You can guess some numbers, or you could obviously just rearrange it and find it there. Just being very careful that you actually read the percentage from that 1 point number. Okay, so we've got some standard forms, we've got some multiplication and some division. I'm going to start with this multiplication. Now I'm primarily thinking this is like a non-calculator style question, because obviously if this was on a calculator you could just type it in nice and easy and write it in standard form. So actually we're going to have to do a bit of a trick here. So 3.2, I can times that by 4 to figure out what my starting numbers would be. So 3.2 times 4, again, you've just got to work that out, whatever method you're used to using. I'm going to do 32 times 4 and hop the decimal back in. So 4 times 2 is 8, and 3 times 4 is 12, and then hop the decimal back in, so it's 12.8. So the answer I get there is 12.8. It's going to be times by 10, and when we're multiplying we can add together the powers here, so 3 plus 4 gives us 7. Obviously though it says to write your answer in standard form, and that number here, 12.8, is not between 1 and 10, so if I hop the decimal in, making the number one place value smaller, I'd get 1.28, and if I make the number smaller, I have to make the power 1 bigger, so it'd be 10 to the power of 8. Okay, so don't be put off by these sorts of questions. Do your multiplication, follow your power rules, and then balance it out. Just remember, if you make the number smaller, you make the power bigger. We'll take this exactly the same approach for this one, except it's a divide. So I need to do 3.6 divided by 4. And again, it's up to you. You can hop the decimal out and hop it back in, but I'm just going to do 3.6 divided by 4 using a bit of bus stop. So 4 doesn't go into 3. So carry the 3, and then 4 goes into 36 9 times. There we go, so it's 0.9. So when we divide that, we get 0.9 times 10 to the power of, and when we're dividing, we can subtract the powers. So the first power there is 2, the second power is negative 3. So just write that down to the side. What have we got? We've got 2 take away negative 3, which is 2 add 3, which gives us a power of 5. There we go, so the power is 5. And then again, we just need to balance that out because obviously this is not between 1 and 10. So I'm going to hop the decimal this way, making it 9. So this time I've made the number bigger. So I need to make the power smaller, so it goes down to a 4. And there's our final answer, 9 times 10 to the 4. And our last question on this section. So we've got in 2008, Alice bought a house in 2008 Alice bought a house. In 2014 she sold it for 20% profit, and in 2019 it was sold at a 5% loss, and it gives us the value that she sold it for. Work out the cost of the house in 2008, so right back at the start. So we had 2008 she bought a house and she sold it for a 20% profit. Then in 2014 it was sold for a 5% loss. And then in 2019 the value of it was 182,400. Right, so at this point in 2019, this cost here to whoever she sold the house to in 2014, this was sold at a 5% loss. So to her, that was only 95% of the value that she bought it for. So if we've got a calculator here, in order to turn that back into 100%, quite nice and simply, we can divide it by 95 to get 1%. So if that there is 95%, we can divide that by 95. So divide by 95, which would give us 1%. So 1% would equal, and we'll just do this on the calculator, 182,400 divided by 95 gives us 1,920. And then to get back to 100%, we just times that by 100. So we can just add 2 zeros on for that. So 1920 with an extra 2 zeros. There we go, so 192,000. So that's the price that it was sold for. Sorry, that she paid for it before. So before that, it was 192,000. That's not a zero. 192,000. And then we've got to think about the original sale in the first place. So that means that 192,000 there was at a 20% profit. So if that was a profit to Alice in the first place, then to her, this amount of money was 120%. Okay, it was 20% more than she originally paid for it. So we can follow exactly the same approach now. If that's 120%, we would divide that by 120 to give us 1%. So 1% here would equal, and we'll just work that out. Divide that by 120, and 1% is 1,600. And again, you can times that by 100 to get 100%. And our original cost up here would be 160, with 2 zeros on the end, so £160,000. There we go, so 160,000. There we go. So that's it using a calculator. That's moving through two reverse percentages there, one with a decrease, one with an increase. You just got to remember, if something's been decreased, then we get this 95%, whatever was left over. And then there was also the scenario where at one point it was increased, making it 120%, that extra 20% there. So this can be done calculator and it can be done non-calculator. The 95% one wouldn't be very nice, but thinking about how you could have done this 120%, which is quite common when VAT is added on, because they often have these VAT questions where they say VAT was added on at 20%. There is a way of doing that without a calculator, and what you could do when that happens is you can divide by 12 and then times by 10. So you could do that without a calculator. You could do a bit of bus stop there and divide 192,000 by 12 and then just add on a 0 when you times by 10. Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided. So x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1 which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. On to expanding brackets. This first bracket we are multiplying everything inside the bracket by b. So b times 3b, well not forgetting there's a 1 in front of that, 1 times 3 is 3, and b times b is b squared. On to the next one, 1b times 7, well 1 times 7 is 7, and there's just that 1b that we're going to leave in there, and we're just going to copy that symbol, which is a plus, so keeping that as a plus. On to expanding below. We have 3y times 5. 3 times 5 is 15, and we've got the 1y there, so we'll leave that as a y. And then 3y times the 4y, well 3 times 4 is 12. Y times y is y squared. And then again copying that symbol as a negative. Expanding and simplifying two brackets, so we'll expand these separately, so let's have a look at the first one. So 3 times 5 is 15, and 3 times 4 is 12. So we have 15x plus 12. On to the next one. Got to be careful with this one because it's saying take away, which means this is a -2 at the start of the bracket. So we're going to times both these pieces by -2. So -2 times 3x is -6x, and -2 times -2 gives us positive or plus 4. Now we just need to tidy all this up, so we have a 15x take away a 6x, and that gives us 9x's in total. And we have a 12 add a 4, and 12 add 4 is 16, that's positive 16, so we get 9x plus 16. Moving over to expanding and simplifying a double bracket. So x times x gives us x squared, x times -5 gives us -5x, 3 times x is positive 3x, and then positive 3 times -5 is -15. And then again we just need to tidy this up because we've got these two x pieces in the middle. So we've got x squared still at the start, but we've got -5x add 3x, which in total is -2x, -5 add 3, and then we've got the -15 at the end. Onto the one below. So we've got some numbers in front of the x's here, so I'm going to do the same process. Let's see if we can move some of this out of the way. Just about. Okay, so 2x times 3x, 2 times 3 is 6, x times x is x squared, so we'll get 6x squared. 2x times 4 is 8x, that's -4, so it's -8x. -3 times 3x is, well 3 times 3 is 9, so -9x. And then -3 times -4 will give us positive 12. 3 times 4 is 12, and it's a negative times a negative. And then again, just tidying this up, we have 6x squared at the start, and we've got -8 take away another 9x. So -8 take away another 9x is -17x. And then we've got that plus 12 at the end, and there's our final answer. And we've simplified it there with the simplifying in the middle. Final answer. Okay, so factorising. We're going to take out a factor and put this into brackets. So we have a look at both these pieces. 3x and 15. We just think what number goes into both of those. They both divide by 3. So we're going to divide this by 3. So 3 on the outside of the bracket, that's the factor we're taking out. 3x divided by 3 is just x. Copy the symbol with a plus, and 15 divided by 3 is 5. And you can check your answer there. You can expand that back out just to check that you do get 3x plus 15. Now this next one says factorise fully, and that's because there's more than just one thing that comes out of the bracket in this one. So in that one above there was just a 3 that came out. So here we're going to have 2 things, and let's have a look at both these pieces. We've got 35x and 21x squared. So they both have an x in, so there's definitely going to be an x coming out. Just need to think with 35 and 21, what's the biggest number that goes into both of those? That is 7. So the highest common factor of those two numbers is 7. They also both have an x in, so we can take x out as well and then follow the same process. So 35x divided by 7x, or what do we times 7x by to get 35x? We'll have to times 7x by 5, but we don't want to put an x in there because we don't want to make that go up to an x squared. Copy the symbol. We times 7 by 3 to get 21, but we want that to be an x squared, so I'm going to stick another x in there with it. That would enable us to get an x squared when we expand that, and there's our final answer, factorised fully. Just a note, if you didn't take the 7x out and you just took a 7 out, for example, and this wouldn't be factorised fully, you'd have got 7 brackets 5x minus 3x squared. And you can see in that bracket there, there's still an x in both these pieces. There's a little hint there that you didn't fully factorise it. So on to solving equations. So when we've got this word solve, it means it wants us to find the value of this x piece just here. So we've just got to reverse the process of what's going on. So at the moment it says 3 times a number, 3 times x, plus 5 is 26. Well, if we get rid of this plus 5 by taking away 5 from both sides, that tells us that 3 times a number, 3x, must equal 21. And that means 3 times a number, so we can reverse this process now by dividing by 3, which I like to write as a little fraction, so divide by 3. And 21 divided by 3 is 7, so we would write x equals 7, and there's our final answer. So have a look at this next one. So 5x minus 2 equals 21. Well, this time to reverse this, we've got 5 times a number, take away 2, so if we add the 2 onto both sides, we get 5x equals 23. And here comes the part where I explain why I like to write it as a fraction as above rather than just writing divide by 3, because in this circumstance 23 doesn't divide perfectly by 5. So if we go divide by 5 again and divide by 5, we have our answer there written for us, 23 over 5. So x equals 23 over 5. Okay, which we could convert back into a mixed number. 5 goes in 4 times with the remainder of 3, so we could write it's 4 with that remainder of 3/5 there. Or I could even write it as a decimal. I could type that into my calculator and turn it into a decimal, but it's fine to leave it as a fraction. 4 3/5 is my answer. So here's one we've got x on both sides of the equation. So in order to make this look like one of the equations from before, we want to get rid of x from one of the sides. Now it doesn't matter which one we choose. I always choose to go for the smallest x. So we've got a 5x on one side and a 3x on the other side. So 3 being the smaller one. So we can take away 3x from both sides. That's smaller x. So if we take away 3x from both sides, well 5x take away 3x leaves us with 2x. We've still got that -3 there, and that now equals +9, so I won't bother putting the positive symbol. However, if there was a negative there, I would keep that in, just to emphasise that it is a -9, that's really important. So now we've got an equation just like the question before, so again we can add 3 to both sides, and we get 2x equals 12, and then we can divide that by 2. Again, I like writing that as a fraction, and 12 divided by 2 is 6, so we can write that as a whole number, x equals 6. Making x the subject of a formula, or any letter the subject of a formula. So this one's y equals 3x plus 5. So essentially, to make x a subject, we want it to say x equals. And we're going to rearrange these pieces and move them around, just like we did on that solving the equation. So the first thing I can do is I can get rid of that 5, just like before, and we can subtract 5 from both sides. Now I can't actually subtract 5 from y, so I'm just going to write that as y minus 5. And that now equals 3x. And just like before, we're just going to divide by 3. So if I divide by 3 both sides, thinking about how I did it before, I wrote it as a fraction like this, and that's what it's going to look like on the other side. It's going to be y minus 5 over 3 now equals x. 3x divided by 3 is just x. We've got x on its own. It doesn't matter that it's on the right hand side. We can rewrite it if we want. We can easily just rewrite x equals y minus 5 over 3, and there's our final answer. Got two slightly different ones here that look almost the same because we've got some fractions going on, but let's see how we treat these ones. So on this left, make x the subject. So again, what I could do is I could get rid of this 3 on the bottom to start with if I wanted, or I could get rid of this 5. I'm going to decide to get rid of the 5, so let's take away 5 from both sides. So if we take away 5 from both sides, we get y minus 5 equals x over 3, or x divided by 3. So to reverse a divide by 3, we're going to have to times by 3. So if I multiply both sides by 3, we'll get 3 lots of, and I'll put it in a bracket now, 3 lots of y minus 5 equals x. We could leave it like that, or we could expand this. We could say 3 lots of y is 3y, 3 lots of 5 is 15, copy the symbol, and then put in our x. Again, we could have done that a slightly different way. We could have times by 3 to start with. You'd have just had to remember at the starting point we'd be timesing this by 3, and we'd be timesing this by 3, just like we did in the end there. But that's our final answer. Now looking at this one on the right, it's slightly different because we don't have the option of getting rid of this 5 on the starting process here, because it's locked in by this divide by 3 on the bottom. So the first thing I'm going to have to do is times by 3 to remove this fraction to unlock what's on top there. And if we times by 3, we get 3y equals, and what's on the top is x plus 5. Now we can finish it off quite nice and easily. We can just take away that 5, and again that's going to make x the subject. So we have 3y minus 5 equals x, and again both of these questions we could rewrite it as x equals at the start if we wanted. So a equals 5b plus 2c, b equals 3 and y equals -2, find the value of a. So we're just having to substitute these numbers in. So we're going to find out what a is. So a is going to equal 5 lots of b, and when I sub a number in I always put it into a bracket. So we have 5 lots of b, which is 5 lots of 3, and then 2 lots of c, so plus 2 lots of -2. We put these in a bracket like that. All we have to do is now multiply these. So 5 times 3 is 15. 2 lots of -2 is -4, and we're adding these together. So 15 add -4 is 11, remembering that these just become a takeaway, so it's 15 take away 4. So a would equal 11. There you go. Just something to remember there. Whenever you're subbing numbers in, always put them into a bracket there, just so that you can sub them in and then deal with the calculations later. So Adam, Brian and Chris are all work colleagues. Adam is 8 years older than Chris, Brian is twice as old as Adam. The sum of their ages is 92. How old are they all? Okay, so we can do this using equations as well. Now it says Adam is 8 years older than Chris and Brian is twice as old as Adam. Now it doesn't say anything about how much older Chris is than anyone else. So if let's call Chris X, then what would Adam be? Now it says Adam is 8 years older than Chris, so Adam would be 8 older than that, exactly 8, so that would be whatever Chris's age is, X plus an extra 8. Then it says Brian is twice as old as Adam. Well, this is Adam here, X plus 8, so Brian is twice as old as that. So twice as old as that would be 2 lots of that, so 2 lots of X plus 8. And we could even expand that out now, so 2 lots of X plus 8 is 2X plus 16. So we have their 3 ages now in terms of algebra. We have Chris being X, Adam being X plus 8, and Brian being 2X plus 16. It says the sum of their ages is 92, so sum being to add them together. So if we add them all up and see what we get, we can have X plus the X plus 8 for Adam, plus the 2X plus 16 for Brian. And it says that they all equal 92. So if we start to simplify this, let's have a look. We've got x, x and 2x, which is 4x. And we have the 8 and the 16, which is 24. So 4x plus 24 equals 92. And now we can just solve this just like before. So I can take away 24 from both sides. Take away 4 is 88, take away 20 is 68. So we get 4x equals 68, and then we just need to divide by 4. So dividing that by 4, let's think, gives us 17. So x equals 17. So it does say how old are they all, so we could finish this off and we could just say, well, Chris was x, so Chris is 17. Adam was x plus 8, so Adam would be 17 plus 8, which is 25. And then Brian is twice as old as Adam, so Brian would be 50. Twice as old as 25, double 25. A nice little quick check there, you could just add those all up. 50 plus 25 is 75, plus the 17 is 92. So I'm happy that that works, it meets all those criteria. Okay, so draw the graph of y equals 2x minus 1 between the values of x equals minus 2 and x equals 3. Now there's 2 ways of doing this. Again, we could make a nice little table, and we've got x values and we've got y values. Remembering this equation just means to find the y coordinate, you do 2 times the x coordinate or double the x coordinate and take away 1. Now it says between minus 2 and 3. So if I'm going to do a little table, I'd do minus 2, minus 1, 0, 1, 2 and 3. And all I've got to do is double them and take away 1 as the equation says. So if I start at the end with this positive number, double that is 6, take away 1 is 5, double 2 is 4, take away 1 is 3. Double 1 is 2, take away 1 is 1. Now you might start to see there's a bit of a pattern here. Look, 5, 3, 1, those are all going down in 2s. So I can just follow the pattern here. 1 take away 2 is minus 1, and take away 2 again is minus 3, take away 2 again is minus 5. And we've got our coordinates here. Just looking at this one, that coordinate is minus 2, minus 5 as a coordinate. And all we've got to do is plot these and join them up with a ruler. So that's one way that we can do it. And I'm going to just draw that in to start with. So minus 2, minus 5's here, minus 1, minus 3, 0, minus 1, and the next few go there. And then nice and neatly with a ruler and a pencil, joining that up with a straight line. Absolutely not like I've just done there, which is absolutely terrible, but as best as you can with a straight line and a ruler. Okay, so that's one way that you can do it with a little table. You can actually do a little trick with this one, which is quite nice if you know what these pieces in there mean. So the 2 in front of the x, let's draw this over here, y equals 2x minus 1. The 2 there represents the gradient, and the minus 1 there represents the y-intercept. Okay, where it crosses the y-axis. So let's have a look there. It does cross through minus 1, so we could have put that point on straight away because we know it goes through minus 1, and then we could have had a look at the gradient, and that gradient of 2 just means for every 1 across, let's think from that point, so 1 across, it goes 2 up, and it goes 2 up. So you could do a little staircase here. You could just go again, 1 across, 2 up, 1 across, 2 up, to keep finding those coordinate points, and then tracing it backwards, so 2 down, 1 left, 2 down, 1 left, and you can draw this little staircase in. That's another way of doing it as well. Slightly different one, so draw the graph of y equals x squared plus 2x minus 3 between minus 3 and 2. Now again, I'm going to do a little table for this. So we have x and y, and it's between minus 3 and 2. So minus 3, minus 2, minus 1, 0, 1, 2. Now this is a slightly more complicated one for us to sub in, because to find the y coordinate you have to do x squared, add 2x, take away 3. So I want to write these down nice and carefully. So I'm going to start with 2 again for the positive one. So we have 2 squared plus 2 lots of 2, take away 3. I'm just going to work that out nice and slowly. 2 squared is 4, plus 2 lots of 2, which is 4, take away 3. So 4 plus 4 is 8, take away 3 is 5. So my answer there underneath the 2 is going to be 5. Now I need to follow this process for all of them, but the one thing I do need to be careful of is when we get to these negative numbers. So up here, where I put 2 squared in, just here, we should really make sure we keep that in a bracket, because as we get down to those negatives, it's going to have a big effect on that, and we'll see what happens when we get to them. Now I'm going to do the other ones a little bit quicker. Let's have a look. So 1 squared is 1, add 2 is 3, take away 3 is 0. 0 squared is 0, add 0 is still 0, take away 3 is negative 3. And here's where we need to be careful. So the first one here is negative 1. So I need to put, if I'm going to do this on a calculator, I'll write my working out down. Negative 1 squared, add 2 lots of negative 1, and then take away 3. Now the reason you have to put this in a calculator is because if you put negative 1 squared without the brackets, it will give you the answer negative 1. It will square the 1 and put the negative with it, rather than doing negative 1 times negative 1. Squaring a negative number makes it positive, so negative 1 squared is 1, add 2 times negative 1 is negative 2, and take away 3. So 1 take away 2 is negative 1, take away 3 is negative 4, so we get negative 4 for that one. There we go. Let's have a look at the next one. Negative 2 squared is 4, add negative 4 is going to be 0, and then take away 3 gives us negative 3 again, and then onto the negative 3. Negative 3 squared is 9, add 2 lots of that, so negative 6, so 9 take away 6 is 3, and then take away 3 again gives us 0. So you can probably see a little bit of a pattern here. Look, if you look at that negative 4 in the middle, either side of that we've got negative 3, either side of that we have 0, and then we have the additional 5 there. But let's just plot these and see what it looks like. So negative 3 to 0 is there, negative 2 to negative 3 is there, negative 1 to negative 4 is here, 0 to negative 3, 1 to 0, and 2 to 5, which is all the way up there. There we go. So this forms a quadratic curve, a parabola, and we just need to draw that with a nice smooth curve as best you can, going through all the points, making a nice smooth curve. And there's our graph drawn. Just as a note, we could also have a cubic graph. So we could have an x cubed up here, and we just treat that in exactly the same way, subbing the numbers in very carefully using brackets. And it tends to be that a cubic graph has this sort of shape. So just be careful. There are some others as well. We could have a reciprocal graph, where we have something like y equals 3 over x, and that has a different look again. It has this sort of curved shape within the positive part of the graph. So there's lots of different graphs that we can have a look at, but just treat it all in the same way and plot the points very carefully, joining them up with nice smooth curves. Okay, so back to a straight line graph. Find the equation of this line and give it in the form y equals mx plus c. So I'm going to use that little trick process that I saw before. We're going to have a look for 2 coordinates here. I've got one coordinate there and another coordinate here. Now if we go across 1 on the x-axis, being careful of the scale here, because although mine goes up in ones, sometimes you might have 2 squares for every one, so just be careful of that. Now it goes across 1 and then it goes up 2. So it goes across 1 and up 2. So every 1 across it goes 2 up. So the gradient, the value of m, is 2. All we've got to find is that value of c, which as we've already said is the y-intercept, and it crosses the y-axis down here at negative 3. So c is going to be negative 3. So I just need to put those all together. We have y equals 2x take away 3. That's the equation of this line. We can do that nice and quickly like that. It goes through negative 3 on the y-intercept, and there's a gradient of 2, which I found between those 2 whole number coordinates there. Slightly different one here because it's sloping in the other direction, but the same type of question. I'm going to take the same approach, so I'm going to find the y-intercept to start with this time, so c equals 1, and then we just need to find the gradient. So let's pick two coordinates. We've got one here and one here, and now this time for 1 across it goes 2 down, so 1 across it goes down 2. So my gradient this time is going down, and we'd say it's -2, so the gradient is -2. So y equals mx plus c, we have y equals -2x plus the positive one there for the y-intercept, and there's the equation of that line. And the last question on these, it says here are the equations of 3 straight lines. It says 2 of them are parallel, and explain which 2 are parallel. So in order for a line to be parallel, it's going in exactly the same direction, and therefore it has exactly the same gradient. So in terms of the equation of a line, which we always want in this form, y equals mx plus c, we want to see this number being exactly the same. So these are all written in different formats. None of them are in the form y equals mx plus c. So we need to actually get them into that form y equals mx plus c. So let's have a look at this first one. And that says 2y. So in order to get that to be just y, we're going to have to divide everything by 2. So if we divide everything by 2, we get 1y equals 3x, I'm going to do 6 divided by 2, and then 5 divided by 2 is 2.5, or I could just leave it as a fraction if I want 5 over 2, which you can write as 2.5 if you like. So this line here has a gradient of 3. Let's have a look at the next one. Y plus 3x equals 5. Well, that's not in the y equals mx plus c format either, because this 3x is on the wrong side of the equal sign. So if we take away 3x from both sides, move that over to the other side, we get y equals -3x plus 5, just popping that plus sign in front of that 5 there. Again, we could have written it the other way around, but let's keep them all aligned. So that is a gradient of -3. So those two definitely aren't parallel. Let's just have a look at this last one. So 3x minus y equals 5. Now this isn't very nice because we've got a negative y here on the left hand side. So I might have to do 2 steps here because I'm going to add y to both sides to make sure that that's positive. So at the moment we have 3x equals y plus 5, or 5 plus y. Let's write y plus 5. And then again we need to get rid of this 5 now because we don't want that there, so we need to move this 5 to the other side. So take away 5 and we get 3x plus 5 equals y. Now it's written the other way around there, but we can rewrite that, we can swap the sides over. So y equals 3x plus 5 is our final answer for that one. And again, this one has a gradient of 3. So the top equation and the bottom equation both have a gradient of 3. So explaining which two are parallel, we would say line 1 and 3, as they both have a gradient of 3. And there we go, both have a gradient of 3. And that's that one finished. Now you can expand any two that you want to start with. I'm just going to go for the first two. So if we expand those to start with, let's have a look at what we get. So 2x plus 3 multiplied by x plus 4. Now if we expand that out, just following normal expansion rules, we get 2x squared plus 8x plus 3x plus 12 on that last bit there. Okay, tidying that up first. So tidy this up, simplify it down, we get 2x squared plus 11x plus 12. Now we can multiply it by the final bracket being up there, the 3x minus 1. So stick this in a bracket and multiply it by 3x minus 1. Again, just take your time with this, it does get quite messy when you're doing it. Okay, so just spend the time, make sure that you get each piece perfect. So let's move this out of the way. And let's just be really, really careful when we expand this now. So 2x squared times 3x gives you 6x cubed. And then 2x squared times minus 1 is minus 2x squared. Onto the 11x. Let's go for a different colour. So 11x times 3x is 33x, so positive 33x squared again. There we go. And then 11x times negative 1 is a negative 11x. 2 more to finish this off. 12 times 3x is 36x. Just about fit this in. And then 12 times minus 1 is minus 12. Right, there we go. We just need to tidy all this up now because we've got a lot of pieces there. We've got the 6x cubed at the start. We've got negative 2x squared add 33x squared. So negative 2 add 33 is 31. So plus 31x squared. Negative 11 add 36 is 25. So 25x squared. Sorry, 25x. And then the minus 12 at the end. and then do just go back, double check, make sure you've added up the pieces correctly, just to make sure that you don't make any mistakes on that final part there. But that's expanding a triple bracket. Just remember to tidy up your first double bracket and then multiply it very carefully by the next one. Okay, so factorising a quadratic, and here we've got a coefficient bigger than 1 at the start. So we just need to have a think about how you do this. You can have 2, 3, 5, you can have any combination of numbers here. But in order to get a 2 at the start there, we're going to need 2x in one of our brackets, and then x in the other. And then we'll just follow the same process, write down the factors of 12, so 1 and 12, 2 and 6, 3 and 4. And we've just got to think, okay, well, one of these numbers is going to double and we want to make -5. Obviously, this one has a -12 at the end, so one's going to be positive, one's going to be negative. And when one doubles, we're trying to make that number 5 in the middle. So it's not going to be 1 and 12, because we can't make 5, particularly if we double the 12. We're not going to make 5 if we've got a 24 and 1. And we're not going to make 5 out of 2 and 12, so it's not that one. Let's have a look at the next one. Doubling the 2 would make 4, so 4 and 6. Can't make 5 out of 4 and 6. Doubling the 6 would make 12, and you can't make 5 out of 2 and 12, so that's not going to work either. Let's try the 3 and 4. Double the 3 would be 6. We can't make 5 out of 6 and 4, so it's going to have to be this last one. Doubling the 4, which is going to make 8, so 3 and 8, and that works. You could do +3, take away 8, that would give us -5. So we want the 4 to double, so we stick that in the opposite bracket to the 2x. We want that one to be negative, so stick a negative with that. And stick your +3 in the other one, and there is your factorised double brackets. Just remember as well, it could say actually to solve something like this, and you can solve by factoring. If it did say the word solve, then we'd have 2 solutions here. For this right bracket, it's nice and easy, just flip the sign, we'd have x equals 4. And for this left bracket here, nice and easy again, it's still flip the sign, still 3, but because of this 2x here, it'd be -3/2, or -1.5. So if it did say solve, that would be an additional step that you could go about. You could say x is -1.5 and x is 4. Okay? Okay, so this question says find the coordinates for the turning point of the graph with this equation. So to find the turning point, we have to do something called completing the square. And sometimes it might say write it in the form, it might say x plus a squared plus b. It might say write it in that form. Okay, and that just means completing the square, and it's how we find the turning point. So in order to do this, you have a look at the x coefficient, which is there, and we halve that number, and we stick it in the start of our bracket like this. So we have x plus 8 halved is 4 squared. And the reason you do that is because if we expand this bracket, and if we think about it to the side, if we expand that bracket there, x plus 4, x plus 4, x plus 4, there we go, we would get x squared plus 4x plus 4x, which would give us 8x, but we would get plus 16 at the end. So obviously it's similar to this part just here. We've still got the x squared, we've still got the 8x, but we've got plus 16. And we don't want plus 16, we want plus 3, because all we're doing is we're rewriting it as in a different form, in this completed square form. So in order to make sure 16 becomes 3, we would have to subtract 13 from this double bracket there. 16 take away 13, give us 3. So that is actually written in completed square form there, and that is how you do it. Now you don't have to fully expand the double bracket. You can just think, okay, well 4 times 4 is 16, that's the number I know I'm going to get at the end. So I'm going to have to take away 13. And our coordinates for the turning point are written within this. So the x coordinates in the bracket there, just like when you're solving, you flip the sign. So the x coordinate is -4 instead of +4. And the y coordinate here is just this number at the end. No flipping of the sign, just writing whatever's there, so -13. There you go, so the coordinate of our turning point is -4 and -13 for the y coordinate. And that's completing the square. Okay, a longer question here, we've got to solve the simultaneous equations. Now when we've got an x squared and a y squared, this actually represents the equation of a circle and the equation of a line. Okay, and that line would be, go sloping this way I believe, let's have a look. Okay, so when you get this sort of scenario here, you get 2 solutions because there's 2 crossover points. There is one scenario where you might get one solution, which is where it's a tangent to the circle, if it just touches at one point. There could even be no solutions, but it would be unlikely we'd be asked to try and solve something with no solutions. So if we have a look at this, we've just got to basically sub one into the other, and we can sub this x minus y equals 2 into the equation of above. So if we actually do that, first of all we've got to rearrange it. Now there's 2 ways. I could make y the subject or x the subject. So I'm going to make y the subject, so I'm going to add y to both sides, which actually that would straight away make x the subject, so let's do that. X equals 2 plus y. Okay, you could even write that as y plus 2 if you prefer, and I'm actually going to do that, x equals y plus 2. Now what we can do is we can sub this little expression here, y plus 2, in place of the x in the first equation, this x squared. So if I just do that, so rather than writing x, I'm going to write y plus 2. So y plus 2 squared plus y squared equals 34. Right, so we've now got an equation that has no x's in, and we know that when we've got an equation that only has one unknown in it, we can definitely solve it. So if we actually go about expanding this first bracket here, I'm not going to write it as a double bracket, I'm just going to go for it. So y squared, we'll get plus 2y, so plus 4y, and plus 4 at the end. And then obviously we've got plus y squared equals 34. Now we can tidy that up, look, because we've got these two y squared pieces. So we can add those together just to make it a bit more tidy. So we've got 2y squared plus 4y plus 4 equals 34. And now we can only actually solve one of these. It's a quadratic, so we can only solve that once it equals 0 at the end, so we need to minus 34 from both sides. So if we minus 34, we get 2y squared plus 4y, and 4 minus 34 is minus 30. And that now equals 0. So we can actually go about solving this now. Now, if in this point here, if we've got a calculator, we could potentially use the quadratic formula, we could factorise it from here, but if you notice that all these numbers here all divide by something, we can simplify it down, because we can divide both sides by anything as the right hand side is just 0, it doesn't change it. So if we divide everything by 2, we get y squared plus 2y minus 15 equals 0, and it potentially just makes it a little bit easier to factorise there. Now if we go about actually factorising this, both are going to have a y in, and we're just thinking what numbers there multiply to make 15, so we've got 3 and 5 or 1 and 15. I'm not going to write down the 1 and 15 because I've already spotted it's 3 and 5, and in order to make 2 we need plus 5 minus 3, and that's going to give us positive 2 in the middle. So we've got two solutions going on here. Obviously it's just these numbers in the brackets, but flip the symbols. So we've got y equals negative 5, and we've also got y, I'm just about to write x there, y equals 3. So there's our two y solutions. We now just need to find our x solutions. Now we've got a nice little formula that we made right at the start here. To find x, we've got x equals y plus 2. So when y is 5, x will equal negative 5 add 2, which is negative 3. So x equals negative 3. And then for the next one, we've got y equals 3, so x equals 3 plus 2, so x equals 5. There you go, so you've got your two solutions and they're written in pairs there. We've got our first solution here, x equals negative 3, y equals negative 5. And we've got our second solution over here, x equals 5 and y equals 3. Okay, so there would be coordinates there. So it might be, if we think back to this graph, it might be that this coordinate where it crosses over is negative 3, negative 5. And this coordinate up here is 3, 5. Okay, so that's what it represents there when we're solving these simultaneous equations. And remember, that could be solved graphically as well. You might be given a diagram, drawing on a straight line, and then just, estimating them or finding them exactly where they cross over. Okay, so there's solving simultaneous equations, and again, there's loads of different variants here. You might have two that have y squared in or y in, and you can set them equal to each other, but this is just one of the harder ones here where you've got to sub one into the other. Okay, and we've got a question here that's shade the region that satisfies all of these inequalities, and we've got these three inequalities there. Now some of these are quite easy to draw, but when we're drawing these inequalities, if we just imagine us to start with that the inequality is an equal sign, it's just going to help us to actually draw the graph. So all I'm going to do is I'm just going to imagine that this one says y equals 2x plus 1. I'm going to draw that line. X plus y equals 4. I'm going to draw that line, and I'm going to draw the line y equals 1. Now the easiest one for us to draw there is y equals 1. Now looking at my graph here, you can't see the number 1, but it's between 0 and 2. Now on the y-axis, y equals 1 is at this point here, and that line y equals 1 is just a nice straight line going through y equals 1. So that's our first one drawn there. Done. The next one is x plus y equals 4. I'm going upwards now, so x plus y equals 4. Well, if x plus y equals 4, that's quite a nice line to draw, because that means when one coordinate's 0, the other has to be 4. So 0 on the x-axis gives us 4 on the y-axis, and 0 on the y-axis gives us 4 on the x-axis. So you've got a nice diagonal line there to draw between 4 on both the axes, and these x plus y equals a number always just connects up the y-axis and the x-axis to those numbers. So we've just got to do a nice neat diagonal going through with a ruler and a pencil, And I'll continue that all the way, oh that's not very good, I'll continue that all the way to the top of the graph there, just a nice diagonal going all the way through. So that's that one done. And the next one there is y equals 2x plus 1. Now you might know little tricks for how to plot these. If not, then I would suggest just drawing yourself a little table and picking some of the values. You probably get away with doing 2 or 3 values. But if we sub in some x values to find our y coordinates here, when x is 0, that would be 2 lots of 0, add 1, y is 1. So if I do this in a different colour, so when x is 0, y is 1, that gives us that coordinate there. Let's pick 2 or 3, let's just go a little bit higher. So when x is 2, 2 times 2 is 4, plus 1 is 5. So when x is 2, y is 5, and that is here. And we could go for some negative numbers as well now, but hopefully you can get a ruler and a pencil and join those up. Now it has a gradient of 2, so I can just look at that coordinate on the y-axis there and go across 1 up 2, which gives us that coordinate there. Cross 1 up 2 gives us the one we've already drawn, and I can follow that pattern backwards as well. But you can draw a full table out for this just to make sure you get it perfect. But there we go, there's my line. I just need to connect those all together nice and carefully with a ruler and a pencil. And there's our 3 lines drawn. Okay, now it says shade the region that satisfies all these inequalities. Now careful, because it's not always that little triangle there that's made in the middle. So I'm going to get rid of these equations now because I don't need them anymore, but I need to have a look at the inequalities. Now all I need to do is pick a coordinate and test it in these inequalities. So if we do pick this one in the triangle here, so this coordinate here, let's do it in a different colour. There's a coordinate inside the little triangle in the middle, which is the coordinate 1, 2. This coordinate here, well x is 1 and y is 2. And if I sub them into these inequalities, as long as they all work, then that's the region I'm going to shade. So if I sub it into that first one there, x is 1 and y is 2, so y is, which is 2, is less than 2 lots of 1, which is 2, plus 1, so 2 is less than 3, and that works, that's correct. Moving on to the next one then, that one works, we've got to test all 3 though. X plus y is bigger than 4, so x is 1, so 1 plus y, 1 plus 2 is bigger than 4. No, that doesn't work. So it can't be inside that triangle there. Although what we have figured out is that the first one works. So in terms of that line, y is less than 2x plus 1 is my pinky red coloured line there. So it's got to be on the right hand side of that. So it can't be this region on the left. It can't be this region on the left. And it can't be this region on the left. So it's got to be one of the other 4. But it's not inside that triangle now, so we can put a cross in there as well. We know it's not that one. So we've got 3 left to have a look at. So if we get rid of this, and obviously always leave your working out down, but let's try another coordinate. So let's try one in this region here, as this one's on the top. So that coordinate there is the coordinate 4, 3. Okay, so this one here, 4 and 3. And if we test those out into all our inequalities and see if they actually work. So looking at the first one, well, we've got y is 3, so 3 is less than 2 lots of x, so 2 lots of 4, 8 plus 1. So 3 is less than 9, and that's correct, that works. Moving on to this x plus y is bigger than 4, so x is 3, so 3 plus 4 is bigger than 4. Well, that's absolutely correct. 7 is definitely bigger than 4, so it works in that one as well. And then on to the last one here, y is bigger than 3. Sorry, y is bigger than 1. The value of y is 3 there on that coordinate, so 3 is bigger than 1. Perfect, they all work. So it's got to be that region there. So we just have to shade this region in. It might say to label it R or something like that, but shade it in and there's your region done. So once you've drawn your lines, just pick a coordinate, test it out into your inequalities, and as long as they all work and they're all correct, then you can shade that region. But do be careful you don't just shade the region of the shape there, like the triangle in the middle, because it's very often not just the shape that's formed. Okay, so we've got solving a quadratic here, and it says give your answer correct to 3 significant figures. Now this gives you a massive hint here, 3 significant figures, that it doesn't factorise. And when a quadratic doesn't factorise, when we've got to solve it in whatever scenario, we've got to use the quadratic formula. So one that you need to remember, you've got minus b plus and minus the square root of b squared minus 4ac all over 2a. And then what I do straight away is I write down the values of a, b and c. So a is 5, the one in front of x squared. So a equals 5. We've got b equals, and you've got to be careful because you've got to get the symbols in, the signs in with it, negative 11. So b is negative 11. And c is, again, that number at the end, negative 13. So first things first, we just need to put them all in the right place. So minus b will be, well, negative b, and b is already negative, so that becomes positive. So b is 11, plus and minus the square root of b squared, and we're squaring a number here, and it's negative, so stick it in a bracket, minus 11 squared, take away 4 times 5 times negative 13, 4 times A times C. So 4 times 5 times negative 13. There we go, and you can stick that all in a bracket if you want, just depends on what calculator you're using. And that's all over 2A, which is 2 times 5, which is 10. Let's just write 2 times 5. Now if you've got a Casio calculator, which hopefully you do because they are the best ones for these higher GCSEs, then you need to just type that in as you see it. So press your fraction button, 11. Let's do plus. I'm going to do the plus version first. So I'm just going to do it once using the plus sign here, and then I'll do it again in a different colour using the negative. So 11 plus the square root of, in brackets, minus 11, close brackets, squared, take away, in brackets, 4 times 5 times negative 13, go on to the bottom of the fraction, and I'm just going to type in 10. And when I type that in, turn it back into a decimal, it says I get 1 which is 3.05192213. And then I'm just going to go back into my calculator, change the plus sign for the minus sign, and we'll write down what we get there. So back into the calculator, takes a bit of a while to get all the way back through this, but it's better than typing it all back in again. Delete the plus, put a minus, press equals again, and I get the answer, negative 0.8519221296. There we go, lots of digits there. So obviously there are two solutions, one with the positive there, one with the negative. Then we've just got to round it, so it says 3 significant figures. So in the first one there, 3, 0 and 5 are my first 3 significant figures. So that would be 3.05 for my first solution. And the second one's a little bit iffy here because we've got a 0 at the start, so it's 1, 2, 3 after the 1. So that would be 0.852 because it's a 9 after it. There you go, and there's my 2 solutions written to 3 significant figures. Just be very, very careful when you're doing the quadratic formula that you do make sure of a couple of things. That is, one, when b is negative, make sure it flips this sign for the first one, and the second one is make sure you put these negative numbers in a bracket. Otherwise it's going to give you an answer of negative 121 there rather than the positive 121. Although if you are squaring a negative number, you could just put 11 squared and forget about the negative, but a little bit of a trick there. Okay, there we go, on to the next one. Okay, so we've got some more algebraic fractions here. Now we're adding these together, so we need a common denominator. So I've got to solve an equation here, but I've got to get these algebraic fractions added together first before I can do that. So if we times both sides, or this left-hand fraction, top and bottom, by x plus 1, and also times the top by x plus 1, that's going to allow me to get a common denominator as long as I times the right by the left denominator as well, which is 3x minus 2, just following normal fraction rules there. So times that by 3x minus 2. Okay, and I've written that next to the top and bottom so I don't forget what I'm timesing by. So on the top there we get 8 lots of x plus 1, and we're going to add to that 6 lots of 3x minus 2. Now because I'm going to get a common denominator here, I'm just going to write that all over my double bracket, which is x plus 1 and 3x minus 2. There we go. Now we can go about expanding all of that and just get it all tidied up. So if I expand the top, we get 8x plus 8. And then we get plus 18x minus 12. And that's going to be all over this double bracket expanded. So x times 3x is 3x squared. I'm going to skip a step here. I'm going to do the minus 2x plus the 3x. Minus 2 plus 3 gives me plus x. And then minus 2 at the end. There we go, that all equals 2. Before I set it equal to 2, I'm just going to tidy up what's on the top there. We've got 8x and 18x, which is 26x. And plus 8 minus 12, which is minus 4. And that's all over 3x squared plus x minus 2. So now I've got a single fraction with a common denominator, and that equals 2. Now we can go about actually getting this into a single line equation and removing this denominator. So I'm going to times both sides by this denominator here. I'm going to times that over, and that's going to put it next to this 2. So it's going to be 2 lots of 3x squared plus x minus 2. So if I rewrite this now as a single line, let's bring it up here. We get 26x minus 4 equaling, and let's expand this bracket here, 6x squared plus 2x minus 4. And if we rearrange this, I'm going to make it equal 0 on the left, so I'm going to minus 26x, and I'm going to add 4 to both sides. So I'm going to minus 26x and add 4, and that's going to allow me to get 0 over here. Obviously it's a quadratic and we need it to equal 0. It doesn't matter whether it's on the left and right, but I want to avoid having a negative 6x squared and having an extra step there. So 0 equals 6x squared. Take away the 26x from 2 gives us negative 24x. And then add 4 to that minus 4 gives us 0. So there we go, it doesn't have a number at the end. So we can actually solve this now. So I can solve this, but it doesn't have a number at the end, so it's not going to go into a double bracket, which it might do if it has a number at the end. So we might have two solutions like in that way, but I'm going to see what solutions I get this way. So if we factorise this to start with, I could actually simplify it. I could divide both sides by 6. And if I do that, let's see what we get. Divide both sides by 6, and we get 0 equals x squared minus 4 x. There we go. Now I can factorise it as well. I've just saved myself a bit of time there. So if I factorise it, we get 0 equals x brackets x minus 4. There we go. So now it's factorised. Hopefully remember as well, we've done this on a couple of other questions. This x value here has no number with it, so one of our solutions is x equals 0, and this one here we flip the sign, so x equals positive 4. And there's my two solutions, x is 0 and x is 4. And there we go, that's that solved. Obviously lots of different algebraic fractions that you could have. You could be timesing and dividing them, adding or subtracting them, solving with them. Okay, always just look to follow normal fraction rules and obviously looking to factorise where possible in these questions. On to some algebraic proof. It says prove that the sum of the squares of two consecutive odd numbers is always 2 more than a multiple of 8. Now there's loads of different questions on algebraic proof, and again I'll have a video with lots of these different examples, but here's just quite a good one here. So it says prove that the sum of the squares of two consecutive odd numbers. So there's a few numbers that you need to know. So any number we refer to as n. An even number, well an even number, if you get any number and times it by 2, it becomes even. So an even number in this proof is we're going to say is 2n. Now to make a number odd, we can just think, well, okay, well times it by 2 makes it even, and then add 1 to it. So an odd number is 2n plus 1. Okay, so times any number by 2, you get an even number, add 1 to it, and it becomes odd. So 2n plus 1 is our little expression we're going to use for an odd number, but it says the sum of the squares. So that means add them together and once they've been squared, and it's 2 consecutive odd numbers. Well, I've got one odd number there, 2n plus 1, so my next odd number would be 2n plus 3. Okay, to get to the next odd number we'd add another 2 to it, so it'd be plus 3 instead. So the numbers that I've got 2n plus 1 and I've got 2n plus 3. And it says the sum of the squares, which means we've got to square them. So I'll square them both, and the sum means to add, so we're going to add them both together. And again, lots of different variations we could have here, but we've just got to square these. So if I square this first one, that's a double bracket, remember, so we'd get 4n squared plus, we'd get 2n and 2n, so 4n plus 1. And for the one on the right here, we'd get 4n squared again, but it'd be plus 6n plus 6n, so it'd be plus 12n. And then 3 times 3 is 9, so plus 9. Right, let's have a look what happens when we tidy this all up. So adding together the 4n squareds gives us 8n squared. 4n plus 12n is 16n. And then 1 plus 9 is 10. Now what I could do at this point is, if it had said prove that it's always even, or prove that it's a multiple of 2, I could just factorise it by 2, and that would show that any number that I sub in there would be multiplied by 2, but it doesn't say that. It says it's always 2 more than a multiple of 8. So I'm looking to try and factorise this by 8. And if you have a look, well, the first piece divides by 8, doesn't it? I can do that. Let's have a look. Divide that by 8, or factorise it by 8, we get n squared. The next one, we can divide by 8 as well. We get 2n. 16 divided by 8 is 2. But I can't divide this last piece by 8. 8 does fit in once though, doesn't it? But it leaves us a remainder, and my remainder would be 2. So if I think about that over here, if I split this number up, and you can do it like this or think of it as a remainder, but if I was to write plus 8 plus 2 instead of plus 10, the 8 would divide by 8, giving me this plus 1, and then I would still have this plus 2 at the end that I've not factorised. And that there proves that. It proves that it's always 2 more than a multiple of 8. If we subbed any number into this bracket here, so any number, it would be multiplied by 8, and then at the very end we would add 2. So that there proves it. Okay, we would multiply everything by 8, meaning it's a multiple of 8. That means multiplied by 8. And then at the end we would add 2. So that proves that any number we sub in there into this expression is always going to be 2 more than a multiple of 8, because we times by 8 and then add 2 at the end. And that's the end of that one there. Again, lots of examples on this that I've got a good video on. Okay, and the last one here, we've got a circle A has the centre 2, 5, and the point P, 11, 8, lies on the circumference of the circle. Find the equation of the tangent to the circle. Now what we know about tangents is they are perpendicular to the radius, okay? So a tangent is perpendicular to the radius. Let's think about that. Perpendicular to radius. Now it can help with these types of questions to draw a little bit of a diagram, just have a think about what this actually might look like. So if I have a think, a bit of an axis here, it says the centre's at 2, 8. So I'll draw a little sketch, not the best sketch here, but 2, 8. And it says the circle, point P is 11, 8. Let's imagine that's over here somewhere. So we've got a tangent coming off the circle, and that's what it looks like. So there's that's a really bad centre there. Let's change that. It's a little bit better. There we go. So this is a really, really general sketch of what it might look like. Okay, and it says that the point, so centre has a coordinate 2, 5, which is there, and point P is up here 11, 8. Now, there's lots of information we can find on this question here, but let's just have a look and just see what it's actually asking. It says find the equation of the tangent. So in order to get the equation of the tangent, I need to know what the gradient of it is. If we think about the radius here, okay, bearing in mind that they're perpendicular, that's what we've already stated, it forms the right angle. Could we find the gradient of the radius? Now we've got these 2 points, so we've got 2, 5, and that definitely attaches to 11, 8, which is on the circumference. So I can find the gradient of those points. I can do the same as we did in the last question. I can do the change in y over the change in x. And that's change in y goes from 5 to 8, which is 3, and the change in x goes from 2 to 11, which is 9. So my gradient is a third. There we go. So my gradient, or m, is a third. So looking at the tangent, which is perpendicular, I can say that the gradient of that is, well, flip it over, would give us 3, change the sign, -3. So there's the gradient of the tangent. So if we stick that into our line equation, as the tangent is a straight line, we get y equals -3x plus c. And we know that it passes through this point 11, 8. Okay, otherwise it wouldn't be on the circumference of the circle there, which it says it is. That's where the tangent meets it. So what I'm going to do is I'm going to stick 11, 8 into the equation of the line, just like I did on the last question. So we get 8 as y equals -3 multiplied by 11 plus c. And again, exactly the same as the last question, we can solve this now. So 8 equals -33 plus c, times in those out, add the 33 over, 41 equals c. So now I've got the y-intercept of that line as well. Now if we put this all together, we've got our equation. So y equals -3x plus 41. There we go. And there's the equation of the tangent. A few other things that you could be asked about this question though. Let's have a look. There we go. You could be asked to work out maybe the length of the radius. So if we go back to our diagram over here, in order to get the length of the radius, we'd have to use a little bit of Pythagoras. So bringing that down there, you've got a little right angled triangle you can draw in, and it goes from 2 to 11, which was a run of 9 there, and a rise of 3, so you could do 3 squared plus 9 squared, so you could actually get the length of the radius there. What would that be? 3 squared is 9, 9 squared is 81, so square root of that is root 90. So you don't need it for this question, but you could say the radius is root 90. You could also be asked to write down maybe the equation of the circle or something like that, but just something else to be thinking about if you ever want to find the length of the radius. You can find it by using a bit of Pythagoras there. Not that we needed it for this question though. Right, okay, that's the end of algebra. Emily and James share some money in the ratio 4 to 7. James receives £21 more than Emily. How much do they share between them? So Emily to James is in the ratio 4 to 7. Now it says that James receives £21 more. And if we look at these two numbers here, from 4 to 7 is an extra 3 parts. There you go, it's an extra 3. So that extra £21 is 3 parts. So if 3 parts of this ratio equals £21, then 1 part must be, to divide that by 3, must be £7. And from there we can work out how much they both receive. If it was 4 to 7, let's get rid of this little bit down here. And each part is now worth £7. Well, 4 times 7 gives us £28 for Emily, and 7 times 7 gives us £49 for James. So Emily receives 28 and James receives 49. It says how much do they share between them. So if we can add these together, it gives us the total amount. So 49 plus 28 gives us 7 and 7, so £77. There we go, so they share £77 between them. A to B is in the ratio 3 to 5 and B to C is in the ratio 2 to 1. Work out the ratio A to B to C. So if we write out A to B to C and start to write what we've got so far, now it says A to B is in the ratio 3 to 5 and then it gives us B to C. So there's an overlap in these, there's a B in both. So I can't put another number just over the top of the 5, so I'm going to start a new level. I'm going to write the other one underneath. So B to C is 2 to 1. Now looking at this, if I can make these middle numbers the same, I can merge these ratios together, I can squish them together essentially. So let's think 2 and 5 can make 10. So if we times the top one by 2, that would make that 5 a 10, and we'd have to times the bottom one by 5. So if we times the top one by 2, that 3 becomes a 6, and the 5 becomes a 10. Looking at the one below, timesing that by 5, 2 times 5 makes 10, which we've already got in the middle, and 1 times 5 is 5, and there's my ratio A to B to C, 6 to 10 to 5. Just have a look to see if you can simplify in any of these questions, but it doesn't actually ask us to simplify it there. So a mobile phone costs £480 in the UK and the same phone costs $600 in America. The exchange rate is £1 to $1.29, where offers the cheapest price. So we have two options here. We could put them both into pounds or we could put them both into dollars. I'm going to decide to put them both into pounds. So as we can see, we've already got the cost in the UK is £480, but we're going to have to convert this $600. So looking at our exchange rate, the actual number itself, we get a bigger number in dollars. So we know that our answer here is going to have to get smaller. So we only have one decision to make, and that is either we times or we divide by this 1.29. Okay, so it's times or divide. Okay, but we know logically we're going to get a smaller number in pounds. So let's go for this. When we do convert back, we are going to divide. So it's going to be 600 divided by 1.29. And we'll do that on the calculator. 600 divided by 1.29 gives us, not a very nice number here, £465 and 12p to the nearest penny. Now it doesn't matter about all the decimals after that, because at the end of the day we're looking at which offers the cheapest value, and as you can see there, £465.12 is cheaper than 480. Obviously there is another way of doing this. We could convert them both into dollars. So instead of doing that, what I could do is times this number here by 1.29, and 480 times 1.29, if again we work that out on the calculator, gives us an answer of, in dollars, $619.20. And again, that's more than $600, so again we would state that it's cheaper in America. In a store, you can buy 2 kilograms of washing powder for £3.40 or 5 kilograms of washing powder for £7.20. Which size is best value for money? Now, there's two ways of doing this. I always like to split the page up. So we've got 2 kilograms or we've got the 5 kilograms. Okay, and the 2 kilograms is £3.40 and the 5 kilograms is £7.20. Now we can either build this up to the same amount of kilograms for each, so we could think actually, well, what if we bought 10 kilograms of each? Well, that would be 5 of these would be 10 kilograms, so if we times £3.40 by 5, we get £17. Or we can have 2 of these, and that would be £14.40. And it's quite clear to see there that if we buy 10 kilograms of each, the 5 kilogram one is our cheaper option there, so we just make that statement, the 5 kilograms is cheaper. There is another way of doing this as well. So if we think along the lines of something easy, let's imagine 2 apples cost £1, so 2 apples equals £1. Well, to work out the cost of 1 apple, we would do the amount of apples divided by the cost, the cost there divided by 2, so we would do £1 the cost, and we divide it by 2 apples. It will give us 50p per apple. And we can apply this same logic up here, so we can do the cost of each divided by the amount. So for the first one, looking at the 2 kilograms and £3.40, so we can do £3.40 divided by 2, and that gives us £1.70 per kilogram. Okay, per kilogram. We can also have a look at the next one in the same way, so £7.20. And we can do £7.20 divided by 5, and that gives us, let's have a look, £1.44. So £1 44 pence per kilogram. And again, you can see which one's cheaper there per kilogram. It's the £1.44, again, the 5 kilogram box. So two different ways, one non-calculator, one with a calculator, to work out a better value. 3 tins of beans and 4 jars of jam weigh 2,080 grams, and the total weight of 5 tins of beans is 1,800. Work out the weight of 1 tin of beans and 1 jar of jam. Well, straight away we can work out the weight of 1 tin of beans from this, because it says 5 tins of beans is 1,800. So if we do 1,800 and divide it by 5, we get the answer 360. There we go. We might have to do a bit of bus stop for that, but we can do that. 5's into 1,800. 5 into 18 goes 3, remainder 3. 5's into 30 goes 6, and then 0, so 360 grams, and that is for the tin of beans. So tin of beans. There we go. It then says 3 tins of beans and 4 jars of jam weigh 2,080 back in the first line. So if we work out the weight of 3 tins of beans now, well, 3 of those would be 360, 360 and 360. And if we add those all up, we get 9, 10, 1,080. So that's the weight of those tins of beans. So if we subtract that away from this original amount, so 2,080 take away 1,080, that leaves us with 1,000 grams. So those 4 jars of jam, so 4 jars equals 1,000 grams. And we want to know the cost of 1. So we can divide that by 4, and it gives us 1 jar equaling 250 grams. So there we go. 1 jar is 250, and 1 tin of beans was 360. Right, so 180 grams of copper is mixed with 105 grams of zinc to make an alloy. The density of copper is 9 grams per centimetre cubed, and the density of zinc is 7 grams per centimetre cubed. Work out the density of the alloy, which is just a mixture of metals. Now, whenever we've got this sort of mixture going on with mass, density and volume, I like to tidy it up in a two-way table. First things first, we definitely need to make sure we write down our formula. So density equals mass over volume. Okay, and you can stick that into a formula triangle if you want, which I am going to do. So density, mass, volume. There we go. So drawing ourselves a little two-way table to tidy this up. Let's have a look. Now for each thing we're going to need a density, we're going to need a mass, and we're going to need a volume. We have the copper, we have the zinc, and we have the alloy. I'm going to split this all up into a table. Right, so let's fill in what we've got. We've got a mass of the copper of 180. We've got a mass of the zinc of 105. It also gives us a density of the copper, which is 9, and a density of the zinc, which is 7. And it wants us to work out the density of the alloy just here. Now we can't add these densities together because the density is going to change as they're mixed together. So if one's 9 and one's 7, the density is going to be somewhere in between that. But what we can work out is the volume of the copper and the volume of the zinc. So looking at your formula, to get volume, we would do mass divided by density. So mass divided by density. So I'm going to do 180 divided by 9 for this one, which gives us a volume of 20. And for the zinc, I'm going to do 105 divided by 7. And 105 divided by 7 is 15. Now masses and volumes can be added together, so we can add these together. We've got 20 and 15, so 35 centimetre cubed is going to be the total volume of this alloy. And we can add masses together, so adding these two together as well. We can do 180 plus 105, which is 285 grams. And then we can finish this question off. It wants the density. Remembering density over here is mass over volume, so 285 divided by the volume, which is 35, and 285 divided by 35 gives us not a very nice number here, but we get 8.142857. It's actually a little recurring number there as well. Now this question would normally ask you to write that to 1 or 2 decimal places, so we would just round it however the question actually asks. But if it doesn't ask us, we write down the full number there, which is 8.14257 with those little recurring dots. David travels from Birmingham to Glasgow. He drives at an average speed of 70 miles an hour for the first 3 hours, and he then drives an extra or a further 150 miles at an average speed of 30. Work out his average speed from Birmingham to Glasgow, so for the whole journey. I'm going to take a similar approach as I did to the density question here, but I'm going to think about obviously using my formula now. So I want to write down my formula, which is speed equals distance over time, And again, we can put that into a formula triangle if we want, and I'm going to do that. So speed equals distance over time. So speed, distance, time. I'm going to use a little formula triangle. So let's see if we can tidy up what we've got here in a little two-way table. And again, for each one, we're going to need a speed, we're going to need a distance, and we're going to need a time. Now we've got the first part of the journey, the second part of the journey, and we've got the total journey. So let's split this all up and write in what we've got so far. Okay, so at the moment we have, he drives at an average speed of 70 miles an hour for the first 3 hours. So this first one here is 3 hours, and he drives at a speed of 70 miles an hour. The second part, it says he drives 150 miles, which is a distance, and he drives at an average speed of 30 miles an hour, so that's going to go just above there. And we want to work out essentially the average speed for the whole journey, which is this one just here. Now again, we can't join together speeds, it's going to be somewhere there in between the 70 and the 30. So let's have a look at what we can do. So this first distance here, let's see if we can work that out. So looking at our formula triangle, distance is speed times time. So we can do speed times time to work out that distance. So 70 times 3, the speed of 70 times 3, says it will go 210 miles. So again, we can add these together to get a total distance at the end there, because that would be 360 miles in total that he's got to do. So all we've got to do is get this total speed here, this total time, and then we'll be able to work out his speed. So looking at this bottom one here, which is the time for the second one. So to get time, you do distance divided by speed. So distance divided by speed will be 150 divided by the speed of 30, which gives us a time there of 5. So that means in total he's going to be driving for 8 hours. Now we can work out his total speed, because we've got his total distance and his total time. And speed is distance over time, so it's 360 divided by the total time of 8 there. And 360 divided by 8 gives us an answer of 45 miles per hour. So I'll just write that down, 45 miles per hour. Again, keeping it all nice and tidy in a table so it all makes sense. We've got some proportion here. 6 taps take 3 hours to fill a tank with water. How long will it take 9 taps to fill the same tank? And then we're going to state any assumptions that we've made. So if 6 taps take 3 hours, it will take 6 times as long as that for 1 tap. So 1 tap would take 3 times 6, which would be 18 hours. It takes 6 times longer. So 1 tap takes 18 hours. So from here, if we know how many taps we've got, we can just divide this 18 hours by however many taps. If we have 2 taps, we can divide it by 2, which would give us 9 hours. We could do 3 taps, divide it by 3 would give us 6 hours. But this particular question here said that there's 9 taps. How long would it take 9 taps? So if we do 18 hours divided by the 9 taps, it gives us a total answer of 2 hours. So these questions are all about working out first, how long would it take 1 tap, or whatever this question's actually about normally. So it says state any assumptions that you've made. Well, I've assumed here that all these taps are running at the same rate. Okay, that's my assumption. All taps run at the same rate. There we go. So obviously in that original statement there, 6 taps take 3 hours. Well, one of those taps might be running a lot faster than the other, and that would change our answer. So we are assuming that all the taps are running at the same rate. So this says James has a bag full of counters. He takes at random a sample of 20 counters, marks them all and puts them back into the bag, and then he takes 30 counters at random, and out of the 35 of them are marked. Estimate how many counters are in the bag. So we're looking at capture, recapture here. Now if we just make a few statements, because we're going to assume that the sample is proportional to the next one that he took as well, or to the rest of the counters in the bag. So initially he takes a sample of 20 counters out of, we don't know. That's what we're trying to work out, so let's call that 20 over x. On the next time, he takes a sample of 30, and 5 of them are marked. So we'll say that that's now 5 out of 30. So out of the 35 were marked, but previously it was 20 that were marked out of something we don't know. But we are going to assume that these are proportional. So in order to work out how many that x value is, we just have to think, okay, well, how do we get from 5 to 20? And we do that if these fractions are equivalent by multiplying by 4. So in order to get that number on the bottom there, we would multiply this by 4, and that would give us 120. So our answer would be 120 counters. Okay, obviously we are making some assumptions here. We are assuming that no additional counters were added to the bag in between the 2 samples, and also none were taken out as well. And obviously there's little silly things like we're assuming that the marks haven't actually come off the counters or anything like that in this time frame. Okay, so that is capture, recapture there. Okay, on to some direct and inverse proportion. So there's two formulas that we can use here. It says A is inversely proportional to B. So it's either going to be A equals K lots of B, or A equals KB, or it's going to be A equals K over B. So these are the two that you have to remember. Now with inverse proportion, it's this one here, where K is being divided by B. So we're going to use that formula, so just make sure you write them down straight away. And then it gives us some values to put in. So it says 15 for A, so 15 equals K over, and it says B is 4. So we can solve this for K, we can times both sides by 4 to isolate K there, and we get 60 equals K, or K equals 60. And now what we can do is we can put that 60 back into the original formula here, and that will give us our formula. So A equals 60 over B. And that is a formula for A in terms of B, and sometimes you might just be asked just to write a formula for A in terms of B, and there it is. But this question says find the value of A when B equals 12. So all I've got to do is stick B equals 12 into my formula down here. So if we do that, I'm going to do it to the side, we get A equals 60 over 12, and 60 divided by 12 equals 5. So our final answer there is 5. So every time you just think which formula we're going to use, plug your pieces in, find your value of K, and then reuse that in your formula for whatever values you need. Okay, so we've got one of these questions with lots of ratios going on. It says in a bag of shapes are either circles or squares, and then they're white or black, and gives us some ratios about them. And it wants us to work out what fraction of all the shapes are white. Now if I start to break this information down a bit, it says fraction, so I'm going to just start to turn these into fractions. Now it says we've got circles and squares, and that's in the ratio 3 to 5. So in total that's 8, so we've got 3/8 that are circles, and 5/8 that are squares. And then it gives us some information, so it says the ratio of black circles to white circles is 5 to 7. So if we have a look at this, we've got black and white, and that is 5 out of 12, 5 plus 7, and 7 out of 12 for the white ones, okay? And then it goes on to the squares, so we've got 1 to 3, and again that's black to white. 1 to 3, so it's 1/4 and 3/4. Now if I treat this just like a probability tree, because it asks me for the total fraction, so if I think, well, what's the probability of picking a white, a white shape? So if we have a look at the circles, we can go through the 3/8 and down the white shapes there to 7/12. So just like on a probability tree, we would do 3/8 and multiply it by 7/12, and that's going to tell me the fraction of circles that are white. I can do the same with the squares, so 5/8 multiplied by that one there, 3/4. So 5/8 multiplied by 3/4, and that's going to tell me the fraction of squares that are white. Now if we work these out, times in fractions is nice and easy. So times in the top, let's just move this to the side a little bit. So times in the top there, we would get 21 over 96. Times in these on the right, we would get 15 over 8 times 4, which is 32. And there's our two fractions. Now just like with probability here, we just need to add these two together, which means we need a common denominator. So not very nice, but you might have spotted here that this fraction simplifies. And if we divide the top and bottom by 3, 21 divided by 3 is 7, and 96 divided by 3 is 32. So actually we can now add these two fractions together. We've got 7 over 32 here and 15 over 32 here. And if we just add those together to finish that off, now that there's a common denominator, 7 over 32 add 15 over 32 gives us a final answer of 22 over 32. And again, you could even simplify your answer there if you want. It doesn't say to, but if we halve both of them, because they both divide by 2, we get 11 over 16. So completely up to you there. We've got two different answers, 22 over 32 or 11 over 16 would be a fine answer there. But obviously in that scenario it's quite nice because one simplified to make a common denominator. If not, you just have to apply your normal fraction rules there to get your common denominator. Last question here, we've got a speed time graph, very similar to a velocity time graph as well, similar process in what we do. So part A says find an estimate for the distance travelled in the first 10 seconds. We know that our formula, speed is distance over time. So actually working out distance is speed times time, which just means all we have to do is work out the area underneath the graph. So normally it would say to split this into equal widths. Okay, I haven't actually added it to this one, but we're going to split it into 5 equal widths. So along the bottom, along the time, it goes up to 10. So each bar I'm going to draw in, I'm going to split it at 2. So every 2 seconds, I'm going to split the shape up and draw it in. Here we go. And I'm going to connect those up together here to make the shape. So I've got a triangle there, a trapezium, another trapezium, another trapezium, and a final trapezium there. And this is going to be quite awkward for me to do on here, but I'm going to give it my best shot. So the height of this triangle, I'm going to write them all in because the base of all these shapes is 2, but I just need to work out the area of all these shapes. So the height of the triangle there, as best as I can see, looks like 27. So the height of that is 27. The height of the next trapezium, as best as I can, is 44. You just need to be super accurate with these. The height of the next one is 50. The height of this next one here is what looks like 44 again to me. And this final height at the end here is 20. So what I need to do is work out the area of them all. So I'm going to label these up 1, 2, 3, 4 and 5 and work out the area of all these shapes. So shape number 1's a triangle. So base times height, 2 times 27 and halve it is 27. So just having a look at the units here, it's meters per second. So the shape 1 is representing 27 meters. Shape 2, we've got the area of a trapezium here. Don't forget the area of a trapezium formula, which is add together the parallel sides, or a plus b, divide it by 2, and then times it by the height, which in this case is the distance between them. Now it's really nice when you've got a distance of 2 between them, because actually dividing by 2 and times by 2 cancel each other out. So actually you just have to add up those two parallel sides. So for number 2, 27 add 44 is going to give us 71 meters. Again, plug it into this formula if it doesn't have a width of 2. Number 3 is going to give us 94, 44 plus 50, so 94 meters. Number 4, 50 plus, number 4 is the same again, 94 meters again. And then number 5 is 44 plus 20, so 64 meters. So all we need to do is add them all up, which I'm going to do on the calculator. So adding all of those up, we've got 27 plus 71 plus 94 plus 94 plus 64, and that gives us a total distance there of 350 meters. Right, there we go, just adding them all up. Let's put that down the bottom there, 350. Okay, so one more thing that we could have a look at on here, and it's part B. It says work out an estimate for the acceleration at 2 seconds. Now this is a bit awkward to do on the same graph, but what I'm going to do is I'm just going to get rid of some of the drawings here around the 2 second mark. Now in order to get an estimation for the acceleration, we've got to draw a tangent at this point here, and that can be awkward. I've obviously just gone up from 2 there to find out where that is. So you just got to get your ruler really carefully and make sure that it just touches at that point and then skims off. Now it's very hard for me to do on the screen here, but that's it, drawing a tangent there. And then all you need to do is draw a little triangle underneath or above and work out the rise over the run, or the change in y over change in x. Okay, so if I just draw this in, and a little tip if it's a non-calculator is to try and get that change in x to be 1. So I'm just going to have a look to see if I can actually do that. So if I go from here, I go across 1, 2, 3, 4, 5 squares, that's a change in x of 1, and I get that distance there, which for me actually perfectly goes to 10. So it's going to be different on the paper because it's quite hard to do it on here, but that gives me a 1 and a 10. And obviously to work out the gradient, you do the change in y over the change in x, and mine comes out as change in y is 10 and the change in x is 1, and it's sloping upwards, so it is positive, and that gives me a gradient of 10. So in terms of an acceleration here, my acceleration would be 10 meters per second squared. And actually for units for acceleration there, so 10 meters per second squared is my acceleration. Okay, so starting this off, we're having a look at working out the length AB. I've got 2 different triangles here, 2 different questions, so let's identify where AB is on the first one. So A to B is this length here. Now when it comes to right-angled triangles, if we've got no angles involved, we can use Pythagoras to work out the missing lengths. So Pythagoras Theorem is A squared plus B squared equals C squared. Now that C represents this longest length here, which we call the hypotenuse, so this is the hypotenuse. I'll label as HYP, so the hypotenuse, and we've got the shorter sides A and B, so 4 and 7. So to work out this length of this hypotenuse, we're going to do 4 squared, add 7 squared, and work that out on the calculator. So 4 squared plus 7 squared is 65. Now that is obviously the length of C squared, so to find out what C is, we just need to square root our answer. So to finish that off, square root of 65, which gives us a decimal for this particular answer, and that gives us a length of 8.06225 and some more decimals. And again, if it asked us to round it to 1 or 2 decimal places, we'd do that in the question. Now moving on to the next one, we've actually got the length of the hypotenuse this time, so we've got 13, and we're trying to find out that this length this time, so A to B this time, is one of the shorter sides. So rather than add them together like we did down here, we're just going to subtract them. So we're going to do 13 squared, take away this shorter side, which is 12 squared, and again we're going to square root our answer. This is quite a good one because it's actually one that could be done without a calculator. We get 169 for 13 squared, take away 144, and 169 take away 144 is 25. Okay, so as you can see, that's given us a square number. So when we finish this question off, to do the square root of 25, we get the answer 5. This is all in centimetres, so that'd be 5 centimetres. So over here our answer would be 5 centimetres. Okay, so Pythagoras, square the sides, add them together before square rooting for the longest side, and subtract them for one of the shorter sides before square rooting. Okay, so working out the size of angle x, again I've got 2 here, and we're looking at parallel lines. As you can see by these arrows here, these lines are parallel. So there are 3 rules that we're going to really look at when we're looking at parallel lines, as well as all our normal angle rules. We've got alternate angles, corresponding angles, and co-interior angles. So if we look at this one on the left here, 110, there's lots of angles we can find now. So all around this point here, we can find all of these angles. Vertically opposite the 110 is also 110, and then next to the 110 on the straight line there, remembering angles in a straight line add up to 180, these would all be 70. There we go. So it's up to you really how you actually find this final one. I'm going to have a look at finding this Z shape here, which is an alternate angle, and alternate angles are equal. So this 70 here is the same as this 70 here. So x would equal 70 degrees in this one. And we've normally been asked to give our reasons there. So my reason may have been angles on a straight line equal 180, and that's how I got the 70. And then I would have said alternate angles are equal, and that's really important the way you say that. So alternate angles are equal. Okay, there are also other ways that I could have done that. If I flick to another colour, we could have said, okay, well if this is 110, well then this here is also 110 because those angles are corresponding. And again, I'll try and draw this on a different colour, but they make this F shape, okay? So that 110 and that other 110 are corresponding angles. So we could have done it that way and then done angles on a straight line. Let's have a look at this other one. So 105 degrees down in the bottom here. So straight away just above that we can find that this angle's 75 because angles on a straight line equal 180. Now if you have a look, we've got a triangle in this question. Now there's these 2 symbols here which tell us that this is an isosceles triangle, and base angles in an isosceles are equal, and it's underneath these 2 little, what I call little eyebrows. Okay, so underneath this will also be 75 because base angles in an isosceles are equal. We can then find this missing angle here because angles in a triangle equal 180, so those 2 75s equal 150, and if we take that away from 180, it leaves us with the other angle in that triangle being 30. There we go. And there's all the angles that we found just using basic angle facts. Now to get that angle x, there's a couple of ways we could do it. We could find this angle here and then do angles on a straight line, or we could again identify that actually we've got one of these alternate angles going up, making this Z shape again. So that's an alternate angle with the 30, so that's 30 degrees as well. So for this one we'd say x equals 30, and again we'd probably give this same reason over here that alternate angles are equal, unless of course we took a different approach, which we could have done. Again, lots of different ways that you can tackle these questions, but a few there that you need to make sure that you try and remember. So when we're looking at circles, there's 2 formulas that we need to know. Circumference equals pi times diameter, and area equals pi r squared. Remember the units for area have squared in, don't they? When we use centimetres, we have centimetre squared, so I always like to remember the little formula for area there is the pi r squared, the one with the squared in. So we're going to work out the area and the circumference of this circle. So to work out the area, we're going to do pi r squared if we start with that. So the area equals pi r squared, and we just need to know what the radius is. So over here the diameter is 8, so we're going to first halve that for the radius, so I'll just write r equals 4, and we'll just got to type that in. So pi times 4 squared. 4 squared is 16, so it'd be pi times 16, and you can just write that as 16 pi. So if it asks you to give your answer in terms of pi, you can just do that, but we want to type that into our calculator if not. So 16 times pi will give us a decimal, which is 50 point. I'm going to round this, but obviously only round it if it says to in the question. It'd be 50.27 if I round it, centimetres squared, and that would be an area there to 2 decimal places. Let's have a look at working out the circumference. So circumference up here is pi times diameter. Now we've been given the diameter is 8, so to get the circumference, we just do pi times 8, and we could just say 8 pi. So we could just say 8 pi, which just means pi times 8. But again, if it asks us to work it out, we're going to do pi times 8 on the calculator. So 8 pi, press equals, and we get, and if I round this to 1 decimal place this time, I get 25.1. And circumference is a distance, it's around the outside, so it's just centimetres, 25.1 centimetres. But again, rounding it to how the question asks, and remembering you can write it in terms of pi, like down here 16 pi, and up here 8 pi as well. Right, working out the area of a trapezium, there's a formula for the area of a trapezium. It's a plus b over 2 times by the height. Or it can be written in a slightly different way. You can say half a plus b, again times in by the height. Now a and b are the parallel sides, which in this case is the 5 and the 9. So we add those together to start with. So 5 plus 9, we halve that. So 5 plus 9 is 14, half of it is 7. And then we times that by the height. And you've just got to be careful here because you are given these 2 lengths on the side and they're really there just to throw you. They're not the height, they're diagonal lengths. This 4 in the middle is what we want, the perpendicular height from the base, indicated by that red arrow there. So 4 is our height, so we're going to do 7 times 4, which gives us 28, and it is an area, it's in centimetres again, so centimetre squared. So just be careful with the trapezium there that you do identify the perpendicular height from the base. So we've got to work out the surface area of this cuboid. Now there's only 3 surfaces we can see. We've got this one on the front, but there's also one on the back that's exactly the same, back here that we can't see. We've got the one on the top, number 2, which is the same as the one on the bottom, and we've got this one on the side here, which is the same as this one that we can't see on the side. So if we work out the area of these 3 faces, we can just double our answer to get the ones on the back as well. So I'm going to do this in steps. I'm going to do the face number 1, which over here is 8 times 12. So 8 times 12 is 96 centimetres squared. Face number 2, the one on the top, we've got 14 along there, and it's not labelled, but this is 12 as well, the same as the bit below just down there. So that's 14 times 12. So 14 times 12, you've just got to work that out, and that's 168. So that's 168 centimetres squared. And then the last one, face number 3 on the side, it's not labelled, but we can label that the height's 8 and the length going backwards is 14, the same as on the length on the top there. So we've got 8 times 14. So 8 times 14 for our last one, 8 times 14 is 112. So that's 112 centimetres squared. And if we add all of these up, 112 plus 168 plus 96, we get the answer 376 centimetres squared. Now you've just got to be careful at this point, obviously don't forget there are 2 of each face, so we just need to double our answer or times that by 2. So times that by 2 gives us a total surface area here of 752 centimetres squared, and there's our final answer for the surface area. So surface area of a cylinder is a little bit more complicated because we've got these 2 circles to work out, and then we've got this shape wrapped around the outside of the cylinder. So the area of the circle we've actually already worked out, pi times r squared is 16 pi, and that equals the circle. Okay, and not forgetting we've got 2 of those, so let's times that by 2, which gives us 32 pi, which again is a number, but I'm just going to leave it till the end for the area of my 2 circles. Now the next thing that I have is this shape wrapped around the outside, and if we were to unravel that, we'd have a nice big rectangle, and the height of that rectangle there is 15. The length of the rectangle is actually the circumference of the circle. So we just looked at circumference of a circle. The circumference is pi times diameter. So I'll do 8 times pi, or 8 pi, the diameter there being 8. It's given us a radius of 4, so we could put the diameter equals 8. But that's 8 pi for the length. And we work out the area of a rectangle just by doing length times width. So to work out the area of this, we'll do 15 times the 8 pi. And that gives us 120 pi for the area of that rectangular part wrapped around the outside. All we've got to do to finish this off is add these 2 together. So we have 32 pi, add 120 pi, and in total that gives us 152 pi. Again, we could just write this as a decimal, but 152 pi comes out as 477 0.5 to 1 decimal place, centimetres squared for surface area, and there's our final answer. So you just got to remember, you obviously got the circles top and bottom, and then to work out the area of the curved part, you need to think about that circumference there being the length of the rectangle. Here we go, working out some bearings. So write down the bearing of B from A. So if I'm at B and I want to go from A, then I'm standing over here at point A. Now there's 3 rules for bearings. They're always measured in a clockwise direction. There's always 3 digits. I always measure it from north. Okay, so they are my 3 bearing rules. So looking here, if I'm standing facing north, which is shown by the north line, I turn clockwise, I'd have to turn this full 60 degrees. So that thing there, 60 degrees, but it doesn't have 3 digits, so I stick a 0 in front of the 60. So it'd be 060 degrees, or 060 degrees. Now the next part of the question says write down the bearing of to A from B. So that means now I'm standing at B. So let's just get rid of these little bits. So this time A from B means I'm standing at B. Obviously, following these rules, if I face north, I've got to turn all the way around this way to get back to the direction of going back to A. So let's have a look at how we can do this. Now, what I quite like to do with these sorts of questions is to think about if I can extend the line slightly. So if I extend the line, because these 2 north lines are parallel, we've actually got a corresponding angle there. So this bit here is actually 60 degrees. So we can think about other angle rules while we're doing this. So from that bit just down to my little dotted line I've put in is 60 degrees. Now because this is a straight line, this extra bit here is an extra 180 degrees. So actually what I've got there is 60 to get me down to here, and then an extra 180. And if we add those together, 60 plus 180, we get a total of 240 degrees. So my answer for that would be 240 degrees, which does have 3 digits, so I can just leave it like that. Of course, there is another way that you can look at this as well. We could think about these 2 angles here as being co-interior that add up to 180. These 2 add up to 180. So this one here must have been 120. So actually I could take away 120 from 360, because that full turn there is 360, and we've got this little bit here as being 120. So I could actually do it like that as well. So there's 2 ways that we could approach it. Okay, so translating a shape by a vector. Now that top number in a vector means left and right, and the bottom number means up and down. Okay, thinking about positive numbers moving towards these positive numbers on the axes, and negative numbers moving towards the negative numbers as well. So 4 moves it right towards the negative numbers by 4. So all I ever do is pick a point, you can pick any, and I move it right by 4. So 1, 2, 3, 4, it's going to end up there. The next thing I do is look at the other number, which is minus 2. Now negative 2 moves down towards the negative numbers. So 1, 2 down, and that means that new point is going to end up just there. So all I have to do is draw this triangle in exactly as it is from that top point. So it goes down 3 and across 2, and there we go. We can just draw it in like that. Not forgetting as well, you might actually be asked to describe a translation, in which case you'd say it just like it says above. You'd say translate the shape by a vector, and you'd say what the vector is. Okay, so reflect the shape in the line x equals 1. Now this is your x-axis and this is your y-axis, so x equals 1 is right there. And the only line that you can do from that point, other than going across the x-axis, and it doesn't say the x-axis, is to go up and down. So x equals 1 is this line here. If you think about any coordinates on that line, the x-coordinate's always 1. So that's our reflection line there. Now we're going to reflect it in that line, which is quite nice and easy to do. Pick a point, and we just go 1, 2 to the line, so 1, 2 away, and just follow that process for all the points. So picking this point, that is 4 away, so another 4 away gets me to there, and the same one at the top, that's 4 away, and 4 away gets me to there, and then just joining it all in, obviously using a pencil for this one, and that would be my triangle. I haven't drawn that in particularly neatly, there we go. Okay, not forgetting as well, though, you could have a line, it could say the line, I don't know, y equals 3, which would be across at y equals 3, which would be across here. There's another couple of lines that we could have as well. We could have this one, y equals x. The line y equals x is the diagonal line here where all the x and y coordinates are equal. So we could have that one as well where we have a diagonal. There's one more that we could have as well. Let's pick a different colour for this. We could have y equals negative x, which is very similar to the one above, but it's pointing in the opposite direction. And if I do that in blue as well, that's going down this way, so we could also have to reflect in a diagonal line, but again you just follow the same process counting diagonally. Okay, so rotate the shape 90 degrees clockwise about the point -1, 0. So first thing to do is obviously to locate that point, which is -1 across, not up and down, so -1, 0 is just there. The next bit, this is a lot easier if we have some tracing paper. So you stick your tracing paper nice and flat over your shape, trace it in, so trace over your shape, stick your pen on that rotation point and just rotate the tracing paper, not moving it away from the pen. So we would rotate it 90 degrees, so it would be facing this way and just making sure it stays nice and flat. And it would rotate the shape, let's have a look, it would go to here on your tracing paper, and then you would just lift your tracing paper up nice and carefully and draw it in at that spot. And again, the same process if you have to describe one of these, you stick your tracing paper over the top and just move your pen into different points, picking places like here and moving it around until you get the one that matches when you swizzle your paper around 90 degrees. And remembering obviously in your description you need to put the amount of degrees, the direction that it's gone in, and that rotation point along with the words rotation. Okay, so enlarge the shape by a scale factor of 2 from the point -4, -3. So let's identify that point first, -4, -3, and then we're just going to enlarge it by a scale factor of 2. So what I do is I pick a point on the shape, normally the closest one, let's say this one here, and I just think, all right, how do I get there from the point? So we go 2 across and 1 up. And I'm just going to do exactly the same again. So 2 across and 1 up. And that there is a scale factor of 2. The first movement to the shape is my first scale factor, the second is my second scale factor there. So if I had a scale factor of 3, I'd do the same again. I'd go 2 across 1 up, and that'd be a scale factor of 3. But this one has just said a scale factor of 2, so I'm going to leave it there. Now if I have a look at the shape that's drawn originally, it's 2 along and it's 3 up. And this is going to enlarge it by a scale factor of 2, which doubles those numbers. So it's no longer going to be 3, it's going to be 6, and it's no longer going to be 2, it's going to be 4. So from this point here that we've got to, all I need to do is redraw that shape in, remembering it was the bottom left corner, this one here. So we'll just need to go 4 across, 1, 2, 3, 4, and 6 up, 1, 2, 3, 4, 5, 6. And then join it all up, nice and neat with a pencil and a ruler, and there it is, enlarged by a scale factor of 2. Just remember, if you have to describe one of these, it's a really nice way of doing it as well. You just pick the 2 corners, get your ruler and a pencil, join them up really nice and neat, pick another one, match it with the appropriate one, and then again join that up really nice and neatly, and it will show you down here, look, where that enlargement point came from. And you can find the scale factor by just looking at the sides. So the side length is 6 here, and the side length is 3 there, and 6 divided by 3 gives us a scale factor of 2. So if it was already drawn in, we found our enlargement point, we just say it's an enlargement, a scale factor 2, and from this point down here, just like it did in the question, enlargement, scale factor 2, and from this particular point. Okay, so moving on to some geometry. So we're going to start off with this volume of a frustum. Now you would be given the volume of a cone formula, and that is volume equals 1/3 pi r squared h, where r is the radius and h is the height. So if we have a look at this frustum here, the only thing it doesn't give us is this length across the top. But if we have a look, the height of the little cone on top is 20, and the height of the big cone, if it was still there, is 40. So it's half the size, so the diameter there is 15. Now in order to work out the volume of a frustum, you've got to work out the volume of the big cone if it was there, and we're going to take away the little cone that's been chopped off the top. So I'm going to start off with the big one. So I'm just going to label this the big cone, and I'm just going to plug the numbers into my calculator. So it's 1/3 times by pi times by the radius squared. Now careful, because it's not 30, it's 15, half of that, so 15 squared, times by the height, which is 40. So typing that all into the calculator, and I can leave that in terms of pi, or I can write out the full decimal, and it comes out as 9424.777961 centimetres cubed. Now for the small cone on top, there we go, we can work out the volume of that as well. So it's 1/3 times pi times the radius squared, careful, so it's half of 15, so 7.5 squared, and times that by the height of that cone, which is 20. And that gives us a volume, and again if we just type that in, let's have a look. So 1/3 multiplied by pi multiplied by 7.5 squared times 20, and that gives us a volume. Again, I could leave it in terms of pi, but 1178.097245, and again that's centimetre cubed. So in order to work out the volume of what's left when the little cone's been cut off the top, we just need to do the big cone subtract the volume of the little cone there. So I'm just going to subtract this away from that, so subtract. And again, I'm just going to do that on the calculator. So 9424.777961. Take away that answer there, leaves us with a total volume of 8,246 point, and I'm going to round it to 2 decimal places, although you would be asked how to round it in a question, but I'm going to go for 0.68 centimetre cubed. Just be careful what the question asks for. Obviously if it said 1 decimal place, it would be 0.7. It might even just say 4 or 3 significant figures, in which case you just got to make sure you just round it how the question's asked. But there you go, that's using the volume of a cone formula on a frustum there, which is a little bit more interesting than just doing a normal cone. Okay, so we've got a transformation here. It says enlarge shape P with a scale factor of -1/2 with the centre of enlargement 0, 0. So always mark out your centre of enlargement first. And an enlargement with a negative scale factor and a fraction here means that we've just got to do this very, very carefully. Now the first things first, you need to pick a point on the shape and just figure out how you get from the centre of enlargement to that point there. And if I just count that, that's 1, 2 to the right, and 1, 2, 3 up. Now all I need to do this, and it's going to be quite small on this diagram, is I just count in the opposite direction by whatever the scale factor is. That's what the negative is. So rather than going from 0, 0, rather than going right and up, I'm going to go left and down. But it's a scale factor of 1/2, so I need to also halve those distances, just as if it was -2, I would double those distances. But for -1/2, so I'm going to go left 1 rather than 2. And I'm going to go down, rather than going up 3, I need to go down 1.5 or 1.5. So 1.5 gets me to there. There we go. So that's 1.5. I'm going to do the next one in a different colour, so I'm going to pick this point here. And let's just think how we get to that. Let's get rid of some of these markings here. There we go. So to get to that, we go 1, 2, 3, 4 across, and 1, 2, 3 up. So I'm just going to halve that again. I'm going to go 2 left rather than 4 right. So 1, 2, and then that 1.5 down, which again gets me down to there. There we go. And that is that point. Then again, I just need to repeat the process for the last one. You might be able to start to do these in your head once you've had some practice, but if we do the last point here, being the top one, let's just see how we get there. So it's 1, 2 across, just like it was to that red one, and then we've got to go up 1, 2, 3, 4, 5, 6, 7. So half of that's going to be 3.5. So I'm going to go 1 to the left. Okay, so I need to go down 3.5, 1, 2, 3.5, just there. There you go. Obviously you can do all this in pencil to keep this all nice and tidy, but when you've got a negative scale factor, you're just going to go backwards in the opposite direction by whatever that scale factor is. Obviously join it all up nice and neat, and there we go. And that is that one there. Just always go back and double check. So it was 7 up, so we went 3.5 down. That's absolutely fine. The other one was 3 up, and we went 1.5 down, half of that. And the other one there, perfect. Okay, so you can see with these, it does actually get bigger, and it gets bigger or smaller, and it rotates 180 degrees, and that's what a negative enlargement does to a shape. Okay, so we're going to have a look at another one here. Okay, so it says describe the single transformation that maps shape B onto shape A. This is quite nice. Hopefully you can tell that it's an enlargement, okay, because obviously one's got bigger and smaller, and we're going from B to A. Now what you can do is you can get your ruler, and we're going to have to try and do this quite carefully, but you get your ruler and you join up the similar points. Now the similar points are here and here. Okay, obviously it's been rotated 180 degrees. Now if you get your ruler and join that up, you end up with a little line like that. And then you just do that for all the other points. So I can probably get away with just doing 2, we'll have to wait and see. So if I join up these 2 similar points here, there we go, they join up just like that. And what you'll find is that there's this little crossover point, and that tells you where the centre of enlargement is. So I know that it's an enlargement, we've already got that, so I'm going to have to state it's an enlargement. Okay, so it's an enlargement. I've got to get what the scale factor is. I haven't got that quite yet, but I'll have a look. We know it's negative as it's getting this 180 flip. So we know it's negative. We'll come up with the number in a sec. And I know where the centre of enlargement is. So centre of enlargement. And we just write down what that coordinate is, and it's 2, 2. So centre of enlargement 2, 2. Now to count that scale factor, we're just going to count this side here maybe, and this side here, and just see how much bigger it's got. So that's gone from a length of 1 to a length of 3, So that is a -3 scale factor. So it's an enlargement, scale factor -3, centre of enlargement 2, 2. And you can use that approach for any of these enlargements, whether it's negative or not. Also, you might just want to note here that if it had been from A to B, it would have been the other way around. It would have gone from 3 down to 1. And my scale factor instead, if I was going from A to B, it'd be exactly the same description there, but my scale factor would be -1/3 because it's getting 1/3 of the size going the other way. Okay, so two different ones, but the description would be exactly the same there. Okay, so we're on to some congruent triangles. It says prove angle ABD is congruent to CBD. Now if you have a look, ABD is the triangle on the left and CBD is the triangle on the right. Now in order to prove triangles are congruent, we need to look for similar sides and similar angles. Now the first one that pops into my head is the line B to D, this line in the middle. Okay, I'll highlight that. This line B to D in the middle is the same for both triangles. So I could prove a side straight away. So I can say a side, I've got BD is the same in both. So both triangles already share a similar side, or exact same side. BD is the same in both. And remember, we're trying to prove that they're congruent, which means that they're exactly the same. So let's get rid of that. We can have a look at another one now. Can we see any other sides that are the same? Well, we've got these little symbols, and I've already got an arrow pointing to two of them really. We've got these little symbols on all of them, which means that all of those lengths are the same length. So we could state any of these are the same now. We've got AB, this one here, number 1, is the same as BC, number 2. So I can do another side. So I can say that AB equals BC, and actually that's given to us in the question. So I would just have to say given in question. There we go. And actually, using that same logic there, we could actually prove that these two down the bottom, which I'll label 3 and 4, are the same as well, because they're all the same length. So I could prove another side. So I could say that AD equals CD, and again, that's given in the question. There we go. So all I have to do is state why that they're congruent there, and I can just say, and I'll just write this down at the bottom, I can say, therefore, they're congruent. Okay, because the SSS rule here, so side, 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 congruent, and we're using the SSS rule. Okay, so there's other things that you can look for as well. You can have a look for angles. Obviously, there's a few of these that you can use. This is just an idea of how to approach it and how to lay it out, just labeling what you found. But because these are obviously isosceles triangles, so this one on the left here, we've got two sides at the same length, so we know that the base angles are the same here. Therefore, as they're all the same length, those base angles must also be the same as the base angles on the other triangle. So we could use that as well. And if those angles are the same, then this angle at A has to be the same as the angle at C. So actually we could prove all of them. So there's a lot of different types of questions here, a lot of different proofs, but there's just an idea of one of them and how to lay it all out. Okay, so in this question, let's have a look. Work out the size of angle BAC. So let's identify that. That is here, BAC. Okay, so we're going to use the formula the other way around this time. So sine A over A equals sine B. That does not say sine B. Sine B over B. Okay, so plugging in our numbers, let's just label it up. So let's call this one A, as the A is next to it, that's fine. And again, I'm just going to write over this one, I'm just going to put B and B. Okay, just because of the way I've written my formula. So then sticking in all the numbers, what have we got? Sine A is sine X, so we have sine X over 20 equaling sine 43 over 14. Okay, so exactly the same approach as we did before. We can isolate the sine X by timesing both sides by 20. And again, you could work that right hand side out and times it by 20, but I'm just going to go stick it up the top there. So we end up with sine X equals 20 sine 43 over 14. And if we type that into the calculator now, what do we get? 20 sine 43 over 14, and we get an answer here. Let's write it over here. So we get sine X equals 0.97428 and a few more decimals. And obviously, just like normal trigonometry when you're doing SOHCAHTOA, to get the actual X here, we have to do the inverse of sine. So we're leaving that number on your calculator. You do shift sine, which gets you sine minus 1. Type in that answer or just press your answer button. So shift sine, answer, press equals, and I get an answer here of 76.9779. And again, a question would ask us to round it here. Just depends. So let's just go to the nearest degree. We go for 77 degrees. Obviously just making sure what the question says here, but let's just round it to the nearest degree there, so 77. Okay, so that's how you use the sine rule. Right, let's see how this question's different then. So work out the length of AB. So this one over here. Now straight away, looking at this, look, we've got a pair of opposites there, but I don't have any other pairs of opposites. I've not got anything opposite my 15, I've not got anything opposite the 12. So I can't actually use the sine rule here, and that is your clue, that is your hint here, that the sine rule's not going to work, and we're going to have to use the cosine rule. So another rule that you need to know, so the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Okay, so a being the side we're looking for, so we'll label this little a and this one big A, ignoring the letters on the triangle, and then labelling the other two sides, and they can be B and C, however you like. And from there, all you've got to do is stick these numbers in. It's actually quite simple to use when you know it. So a squared equals b squared, which is 15 squared, plus c squared, which is 12 squared, minus, and I'm going to stick this bit in brackets, 2 times 15 times 12 cos a, which is down here, which is 20. There we go. Right, so sticking that all in the calculator, let's have a look what we get. So 15 squared plus 12 squared minus 2 times 15 times 12 cos 20. Press equals, and I get a squared equals 30.7106 and a few more decimals. Now obviously that is a squared, and we don't want a squared, we want to know what a is, so we just need to square root both sides now. So square root, leaving the answer on your calculator, square root answer, and we get a equals 5.541719. And again, obviously you'd be asked to round this in a particular way in the question. Let's go for 2 decimal places, so a equals 5.54 centimetres. Right, there we go, and there's using a bit of the cosine rule. Okay, so working out the size of angle BAC, which again is this one at the top, and again just having a look, there are definitely no opposites because we've got no other angles, but the angle that we're looking for is going to be our A, and it is opposite 9. There we go, so the others can be B and C again. Now obviously here we're looking for an angle, so it's up to you if you choose to learn the formula. I tend to find that I just learn this formula, a squared equals b squared plus c squared minus 2bc cos a, and then I'm quite happy just rearranging that to get cos a on its own. So in order to do that, I'm going to get this whole minus 2bc cos a, I'm going to add it to the other side, so we get a squared plus 2bc cos a equals b squared plus c squared. Now I can get rid of that a squared, so we can minus a squared from both sides, so minus a squared, and you get 2bc cos a equals b squared plus c squared minus a squared now. And now you can finish off this rearrangement. You can divide by 2bc just to leave you with cos a. So cos a equals b squared plus c squared minus a squared over 2bc. It's up to you. You can choose to just learn that formula if you want, but that's the formula we're going to use to find an angle. So plugging in all these numbers then just into my formula there, we'll get cos a equals b squared plus c squared, so 10 squared plus 5 squared, minus a squared, so minus 9 squared, all over 2 times b times c, so 2 times 10 times 5. Nice and easy typing that into the calculator, so fraction button, 10 squared plus 5 squared, minus 9 squared, all over 2 times 10 times 5, and that equals, let's have a look, so cos a equals 0.44, and then same process again, we need to do the inverse of cos, so cos minus 1 of your answer, and you get, let's have a look, shift cos, answer, and I get 63.896 There we go, degrees. And again, we could round that, so we could just say 63 point, and let's just go to one decimal place, 63.9 degrees. Again, just reading the question. And that's how to use the cosine rule for finding angles. Moving on to the area of a triangle. So your area of a triangle formula, obviously not half base times height because we don't have the height here. So for any triangle, the area is half AB sine C. So half AB sine C, another formula there that you need to know. And let's just have a look at how we apply that. So sine C, this time the angle that we're going to use is going to be our C. So we'll call that C. This would then be little c, and the others will be A and B, and they can be A and B in either order. And then it's as simple as just sticking those numbers into a formula. So it's half times 5 times 8 times sine 41. There you go. Type that into the calculator. So half times 5 times 8 times sine 41. And we get the answer 13.12. If I round it to two decimal places, it's area, so that's meters squared, just being careful of the units. So 13.12 meters squared. There we go, there's using the area of a triangle formula. Question like this though, you might be given the area of the triangle. So it says the area is 80, so we're working backwards a little bit here. So we're going to use half AB sine C again. So half AB sine C, but this time it gives us the answer. So the answer to that half AB sine C has to equal 80. So let's just plug in all the numbers here. Again, C being my angle, and then A and B being my other lengths. So if I was to type this into the formula, we'd have a half times 11 times 16 times sine C, and it would equal 80. Now I can't actually work that out, but what I can do is I can work this bit out. So if I do a half times 11 times 16, we get the answer 88. So we have 88 times sine C equals 80. So we can rearrange this. Look, we can get both sides and divide them by 88, and that will just give us sine C on its own. So sine C equals, and 80 divided by 88 is, let's leave it as a fraction. Well, actually it is a decimal there, but it comes out as 0.90, and that is actually 90 recurring. There we go, I'm just going to leave it on the calculator screen. And then obviously to finish that off, you do the inverse sign again, just like we have on these other questions. So I'm going to do that over here to the left. So sine minus 1 of this number here, which is actually also a fraction, it's 10 over 11. Sine minus 1 of 10 over 11, or that 0.90 recurring. And we get the answer of 65.38 degrees. There we go, so we can find an angle as well, just working backwards if we're given the answer. And you can apply that logic there to lots of different questions where it gives you the answer and you can use your formula backwards, just dividing everything over to the other side. And the last question here is just involving some circle sectors, but also involving a little bit of trigonometry as well. It says that this is an arc of a circle centre 0, and it wants us to work out this shaded region. So if we can work out the full sector, we can take away this unshaded triangle. So to work out the area of a sector, we would have to do pi r squared, so not forgetting your area of a circle formula, pi r squared, and multiply that by whatever fraction of the circle this is. Now it says 35 degrees over there, so it's 35 over 360. So if we plug those numbers in, it will give the area of the sector. So we've got pi times 80 squared, it's in metres, multiplied by 35 over 360. Now if we type that in on the calculator, let's see what we get. Pi times 80 squared times 35 over 360, and we get the answer 1954.7, and let's round it to two decimal places, 77. Obviously just be careful what the question says again, and that's meters squared. Then we can work out the area of the triangle, and obviously not forgetting, just because it's not just a triangle on its own, we can still use our half AB sine C. So we can use half AB sine C to get this one. And if we plug the numbers in, 35 there is our C. And because it's a circle sector, A and B here are the same because it's the radius of the circle. So we can do half times 80 times 80 times sine 35. There we go, and if we type all that in, 0.5 times 80 times 80 times sine 35, we get the area of that triangle there, which is 1835.44 meters squared. And then to finish that off, we can do the bigger shape, the sector, subtract the area of the triangle, So 1954.77, take away this 1835.44, and that leaves us with an overall area here. Let's work it out. 1954.77, take away answer, and we get 119.325 meters squared. And there we go, and obviously just rounding that however you'd been asked in the question. So there's quite a large selection of geometry questions there. Now this question is very similar. It shows the height of 30 students. It says calculate an estimate for the mean, and then again write down the modal class interval. So the reason it says to find an estimate for the mean is because we can't get an exact mean because we don't actually know, particularly looking at just this first row, what that person's height actually is. There's one person between 130 and 140. There could be anything, 132, 138, anything in between. So what we do is we pick the midpoint. So in between 130 and 140 is 135, and we're just going to use that as an estimate for the height of that person. And we'll do the same for all the others, 145, 155, 165, and 175. And we'll just treat this in exactly the same way as we did before. So one person at 135, 7 people at 145, and we're just going to times across for all of these again. So one lot of 135 is 135, 7 lots of 145 is 1015. Again, I'm just doing this on the calculator. 8 times 155 is 1240. 10 times 165 we can do 1650, and 4 times 175 gives us 700. And again, from here it's just the same process. We add those all together. So 700 plus 1650 plus 1240 plus 1015 plus 135 gives us a total there of 4740. And again, it said that there were 30 students there, which we can find from the bottom. So finishing the sum exactly the same as before, 4740 divided by 30 will give us an estimate here for the mean, because again we have just guessed what their heights are as using those midpoints, which gives us 158. And again, that answer there has to fall in between this range here, which starts at 130 there and ends down here at 180, so it has to fall in between, so 158 centimetres. Now the next bit says write down the modal class interval. Now the word class just means group, so it's the modal group, which group is the most common, and that's here with these 10 people. So all I have to do is, and I've written over the top of it now, but all I have to do is write this group down here. So the modal interval, okay, is that exact thing there, and I just write it down word for word, 160 to, what was in the middle, h in this instance, to 170. And that would be my modal class interval just there. Okay, so reading from a stem and leaf, it says the speed of 27 cars, work out the median and work out the range. So to work out the median, I want to know which one's in the middle. We can take quite a nice approach for this. We can just cross numbers off either side until we get to that middle number. So if there's 27, I'm going to cross off 10 from each side at least, so I can start to get from the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then going from the back, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm just going to do one from each side until I get one in the middle. So 1 and 1, 2 and 2, 3 and 3, and I'm left with this one here. Don't forget the key though, it says 3-8, or 3 line 8 means 38. So that's next to the 5, so it's 5 and 6, which is 56. So the median there would be 56. Working out the range, we want to look at which one's the smallest and which one's the biggest. Let's have a look. If I get rid of some of my lines here, the smallest number there is 38, the biggest is 70. So to work out the range, which I'll do up here, so the range will just be 70 the biggest, take away 38 the smallest, which is 32 as my range there. Again, there's median and range from a stem and leaf. Okay, so drawing a pie chart. We've got to draw an accurate pie chart for this information. So the good thing about a pie chart is these numbers in the table are always going to fit into 360. This is quite a small one here, because if I add these up, I've only got 10 people in this pie chart. It looks like the type of fruit that they prefer maybe. So we've got 10 people, so all I want to figure out is how many times this fits into 360. So whatever that number adds up to, I can do 360 divided by that number, and it tells me that each person here represents 36 degrees. So all I want to do is times the amount of people by 36 in each scenario, we'll times them all by 36, and that will tell us the amount of the degrees I need to draw in my pie chart. So 2 times 36 is 72, 5 times 36 is 180, and 3 times 36 is 108. And again, it's quite a nice check here. If you add those up, they have to add up to 360. And if we add them up, let's have a look. 108 and 72 makes 180, plus the 180 is 360 degrees. So that's a nice little check there. You can tick that off, happy with that as 360. Now moving on to the next part, we actually have to draw the pie chart. So whatever kind of protractor you've got, you need to stick it over the top using this first line here as your starting line and measure out 72. Now if I guess where it's going to be about there. And all we need to do then is draw inside that piece of the pie what that represents. So that represented apple and it represented 72 degrees. Then drawing in your banana there, which is 180, which is going to be a straight line going the other way. Again, measuring from this line as your new starting point, and that is going to be banana. Ooh, banana, and that is 180 degrees. And then your final one there, because I've only got 3, the final one's done for me, although stick your protractor on and just make sure that this distance here is in fact the 108 degrees that we want, just to make sure you've done it all correctly. And you'll get an orange in there with 108 degrees. Now just remember, when it comes to a pie chart, if you ask then to compare this against another group, let's imagine we have another pie chart. I'm going to draw a really rubbishy one over here. We have another pie chart, and let's say that this size is apple now. So we've got apple, banana, and orange, and it says something along the lines of more people like apple in this pie chart. Now without any numbers we can't actually make any statements like that, so if you are given a pie chart to compare, just remember without any numbers you can't actually make a comparison, because there might only be 5 people in this pie chart, for example, in which case it might not necessarily be more people. Okay, so we're going to have a look at some statistics. This is going to be quite a short one. We've only got a few questions to have a look at, and we're going to start with a box plot. So on here we've been given some information about some time in seconds that 15 people wait to be served at a garden centre, and it wants us to draw a box plot for this part A. So we've been given a list of numbers for those minutes, and you've just got to make sure that they're in order, because we need to find a few values. We need to find the lowest value, the highest value, the median, and the 2 quartiles, the lower and upper quartile. So we can quite easily see that they are in order, so we can get the lowest and the highest value from either side, and they're going to form the ends of our box plot. So just very carefully on your scale here, drawing the ends in here, and 44, just make sure the scale goes up in ones. It does. I'm going to do it as best as I can here, and that's our 44 there. Now we need to find the median. So with 15 people, we just want to find where that halfway point is. So all you've got to do is add 1 and halve it. So 15 plus 1 is 16, divide it by 2, and that's going to be our 8th person. So we just need to go along the box plot and find where the 8th person is. So 1, 2, 3, 4, 5, 6, 7, 8. So 25 is going to be our median. That's quite nice. It's halfway between 20 and 30. Draw an end nice and neat there to form our median. Now we just need to find where the quartiles are. So on that lower half, okay, the lower part or the lower quarter here, if I try and highlight that, we've got these numbers here, and there are 7 numbers there if you just count them up. So 1, 2, 3, 4, 5, 6, 7. So again, finding the halfway point, we can do 7 plus 1 and divide it by 2, which gives us 4. So we want to find where the 4th person is for that lower quartile. So 5, 9, 11, 14. There is our lower quarter there. So marking that on the 14th person. 1, 2, 3, 4. And then looking at the higher quarter there. 27, 27, 28, 30. Okay, so once you've marked all of those on there, you've got to join up your little box. There we go, making it look like the one that you can see below, and then join up these parts here, and there's your box plot drawn. Okay, moving on to the bit below. Now I haven't added the question in here, but quite often it says to compare the box plots. So it says here, the box plot below shows the distribution of times served at a different garden centre. And it would usually say to compare them. Now there are 2 things that you want to compare when you're comparing a box plot. One of them is the median. So if we have a look, our median here is sitting on 25, and down it's sitting here on 21. Now I don't have to mention any numbers, but I would mention number 1. I would say that Rose, I'll just call it Rose. Rose has a higher median wait time. Okay, so a higher median wait time. Okay, make sure that you mention some context. Obviously don't just say it has a higher median. What's the story actually about? It's about the wait time at a garden centre. So Rose has a higher median wait time. The next thing we have a look at is the distance between the quartiles. And again, I don't have to mention any numbers, but I just have to think, this is the distance between the quartiles. It's called the interquartile range. And on the one below here is the distance. Now hopefully you can see there visually that on the Greens Garden Centre there is a higher interquartile range, meaning that the data is more spread out, and you want to mention that word spread out. So number 2, my comparison here, Greens has a higher, I'm going to abbreviate it to IQR, interquartile range, meaning the data is more spread out, or meaning the wait times are more spread out. There you go, more spread out, and mention that word there, spread. There you go, so more spread out, and that is drawing a box plot and also making a comparison between the two. Let's move on to our next one. Okay, so the last one here, we're going to have a look at a reverse mean question. Now I know it's a reverse mean when it starts to talk about actual means. It says that the mean for certain people is, and then starts to give us some information. So it says there are 20 men, 20 women and 10 children, and they take part in a quiz. And then it gives us the mean score for the men, the mean for the children, and the mean for the whole group. And it wants us to work out the mean score for the women. So that's what we want to work out eventually. So all we got to do is think in reverse for this. So when you're working out the mean, you get the total and you divide by how many people there are. So if we think about the men, you don't have to write it like this, but just so you have an understanding of this, you would get the total, which we don't know. You divide it by the 20 men, and it says it gives us an answer of 6, the mean for the men. So if we reverse this round, times both sides by 20, so times by 20 gives us a score of 120 for the men. So that's the total score for the men. We could then do exactly the same for the children. I don't have to write out this little bit of algebra every time, but if I just think, okay, well the children then, I just know I need to times the amount of children by the mean. The mean is 4 and there are 10 children. So 10 times 4 gives us a total score of 40 for the children. There we go. Now we don't actually know what the mean is for the women, that's what we're trying to work out, but what we are given is this last bit of information here, which says the mean for all of them is 5. Now in total, if we have a look at the question, it says there are 20 men, 20 women and 10 children. So that's 50 people with a mean of 5. So that we could do 50 people times the mean, which is 5, which gives us a total score of 250. So that's our total there. So now we know the total score, we know the score for the men, we know the score for the children, so we can actually work out what score the women got. So if we do this to the side, we know we have to do 250, take away the 120 that the men got, and take away the 40 that the children got. And if we work that out, 250 take away 120 is 130, take away the 40 leaves us with a total score of 90 for the women. So the women scored a total of 90, and it says that there are 20 women. So to work out the mean for them, we've got 90 is their total score divided by 20. And again, depends whether you have a calculator or not here, but even if you don't have a calculator, we can do this one. We can cancel off the 0 top and bottom, and it's 9 over 2, or 9 divided by 2, which is 4.5. There we go. So the women have a mean of 4.5, and that'll be our final answer there to finish that off. There we go, and that's our little bit of statistics done. Okay, so we've got a lot of information here. 100 students are in a year group, and then we've got some information about whether they wear or do not wear glasses. And it wants us to work out the probability of choosing a boy who wears glasses. And when you've got a lot of information like this, I like to organise it in a two-way table. So I'm going to put this all into a two-way table. Again, you could use a frequency tree, but I'm just going to opt for using a two-way table. So we could have boys and girls on the side. Again, you could have them at the top, but I'm going to put them to the side. And then you've got a total down the bottom. And then we've got whether they wear or do not wear glasses. And again, we've got a total here. So all I'm going to do is put the numbers within the question. We've got 100 students in the year group. 42 of them are boys, 8 out of 100 students wear glasses, so 8 students here wear glasses, and 52 of the girls do not wear glasses, so 52 just here. Now that's everything in the question, we've just got to fill in all the missing numbers now. So if there are 42 boys here, that must mean that there are 58 girls, and out of those, 52 do not wear glasses, so that must mean that 6 of them do. Now again, we've got 8 that do wear glasses, 6 of them are girls, so 2 boys must wear glasses. And again, going along this way, that has to add up to 42, so that must be 40. And then moving downwards or across from another direction, I could add those together to make 92. And a very quick check here, those two add up to 100, so that's right, we're happy with that, we can tick that off. Now it says, work out the probability of choosing a boy who wears glasses, and one of the students is picked at random while two of the boys wear glasses. So that would be 2 students out of the 100 students that we've got here. You don't have to simplify that, but just a quick note, it could have said in the wording here, it could have said, rather than saying one of the students, it could have said one of the boys. Now if it had said it, maybe it had picked one of the boys, then that would have been out of 42. So it would have been 2 over 42. But it just depends on what the wording says. So it does say one of the students. It doesn't dictate whether it's boys or girls, so it's out of 100. So when we do a frequency tree, it looks a little bit different. So we're going to split it off in a tree. So we're going to split it like this. And we've got 60 people to start with, and I'm going to put that in straight away. And then we're going to split it off into males and females. Okay, so I'm going to split that, male and female. I'm just going to write at the end of those trees how many of each there are. Okay, and from there, we're going to have a look at the options that they could have picked. So this was about the different countries. So we've got Britain, we've got Italy, and we've got Spain. Okay, and I'm just going to put a little circle coming off all of these. It's not quite as nice and neat and tidy as the table, but I'll try my best. And then off the females as well, we've got the 3 different options. There we are, so Britain, I can't remember what order I said now, Britain, Spain and Italy. So I'm just going to label that up so I don't forget. Britain, Spain, Italy. That is not a B, let's go back and do that. Britain, Spain, Italy. There we go, so we just want to start filling in these numbers just like we did before. Let's have a look. So we've got 38 of the people were male. So straight away we've got 38 that are male that can go in there. It said 11 of the 32 people who said Britain were female. So we don't have a total column this time, but we've got 11 were female. So down the female that said Britain, we've got 11 there, and it's told us it's out of 32, so it's told us that these 2 here have to add up to 32. Okay, I'll just leave that there for the moment, we'll deal with that in a sec. Then it says 8 males said Italy. So in the Italy column, in the males one, we've got 8 there. There we go. And 12 people said Spain. So again, let's have a look. That says these 2 have to add up to 12. Okay, right, that's that dealt with. Right, okay, so it doesn't quite look as nice. I'm trying not to be a favouritist towards the two-way tables, but I do much prefer a two-way table for this particular type of topic. But as I said, we do still need to know how to use these, so we're going to keep going with it and see what we get. So obviously we've got the 2 circles there for Britain. Let's just highlight that, and they've got to add up to 32. Now the one down the bottom there is 11, so the one at the top has to be 21. There we go, and that makes sure that they add up to 32, and we've dealt with that bit of information there. Let's see what else we can figure out then. So we've got 38 males. So let's have a look. They've got to add up to 60, the circle before it. So that is going to make an extra 22 there for the females. Next bit of information, let's have a look at what we can figure out. We can figure out this box here, okay, because they've got to add up to 38, those 3 boxes. Now at the minute we've got 21 and 8 in the males branch there, that adds up to 29, so we need an extra 9. There we go, that makes sure that adds up to 38. And obviously we've got this information here that they both have to add up to 12. We've now got the 9, so that has to be 3. And then those 3 boxes on the female branches have to add up to 22. They add up to 14 at the moment, so that's an extra 8. There we go. So obviously now we've got our frequency tree done. It says one of the females is chosen at random. Okay, so, and again, let's have a look. Let's just highlight this. The female box is out of 22. And it says what is the probability that they choose Spain. There we go, so Spain is the 3 just there. So we just use those 2 numbers, 3 out of the 22. Okay, so again, very similar to what we did before, but obviously we were using a frequency tree instead this time. Okay, so the next one, we've got a lot of information here. So it says Sophia asked 50 people which drinks they like best, from tea, coffee and milk, and all 50 people that she asked liked at least one of the drinks. Then it starts to talk about all these different ideas about what drinks people liked and whether they liked all 3, whether they liked tea and coffee. So we're going to go through all of them there, but ultimately it says she selects at random one of the 50 people, work out the probability that this person likes tea. So we need to figure out from all this information how many of the people there like tea, and it doesn't explicitly tell us how many like tea. So when we've got these 3 options like this, the best way for us to organise this is in a Venn diagram, and specifically a 3-way Venn diagram. So we need to draw, I'll do this as best as I can, a Venn diagram that's going to allow us to have 3 elements in there, and you just need to make sure with a Venn diagram you draw your little box around the outside. There we go. Now I want to keep this all nice and neat and tidy, so I'm going to label them. I'm going to call this one the milk, this one the tea, and this one down here, the coffee. I'm just going to go through the list and just start to tick things in when I know that I've got them there. Now the first piece of information it tells us, and if we go through this step by step, it says all 50 people like at least one drink. So that means we know that there's going to be nobody in the outside, so 0 on the outside. Next thing we've got is 19 people like all 3 drinks, and that's a key piece of information there because we can definitely put that in straight away. The people that like the all 3 are right smack bang in the middle there, so we've got 19 in the middle. So we've dealt with that one, and you can tick them off as you go or highlight them. So that next one says, it says 16 people, I'm going to swap to a different colour here, it says 16 people like tea and coffee but don't like milk. So the people that like tea and coffee are going to be in the crossover between the T and the C circles, but they do not like milk, so that's fine, we can put them in there, 16 that like tea and coffee but do not like milk. There we go, tea and coffee but don't like milk. It then says 21 people, let's try swap to another colour, 21 people like coffee and milk. Oh, I'm just going to get rid of that because I've got too many things going in there. I've got 21 people like coffee and milk. So 21 people that like coffee and milk, well let's have a look. Coffee and milk is this crossover here, but also includes that 19. It doesn't say 21 people like coffee and milk but don't like tea. So if 21 people like coffee and milk, well, we've already got 19 in there that like coffee and milk, so that's going to be an extra 2 that makes that up to 21 there in that little crossover with coffee and milk. 19 of them also like tea, but then 21 in total like coffee and milk. So that's that one dealt with. How many have we done now? We've done all 4 of those. There's lots on here. On to the next one. We've got 24 people like tea and milk. So 24 people like tea and milk. Let's have a look. Well, tea and milk is this one here. But again, it doesn't say that they don't like coffee. So 24 people like tea and milk. 19 are already in there. So that's going to be an additional 5 people there. And that makes up 19 and 5. That's 24 people in total that like tea and milk. On to the next one. We've got 40 people that like coffee. Well, we've already got 3 people in our coffee circle there. We've got the 2, we've got the 19, and we've got the 16. So in total that adds up to, let's have a look, 2 plus 19 is 21, add the 16 is 37, and it says 40 people like coffee, so that's going to be an extra 3 that make that coffee circle up to 40. Next one, this one's a nice easy one to finish. We've got 1 person likes only milk. So in the milk we've got 1 person, and then we're given no more information. But there is this missing number here in the T. Now just remember, it did say in the question that she has 50 people. So if we add up all the numbers we've got 1 plus 5 plus 2 plus 19 plus 16 plus 3. And all of that adds up to make 46. And in total we have to have 50 people in our Venn diagram. So just in the T one there, that's an additional 4 people to make sure that we have 50. So we just did 50, take away 46, which left us with those remaining 4 people. So we filled in our Venn diagram. Now it says Sophia selects at random one of the 50 people, work out the probability that this person likes tea. Well, that doesn't say just likes tea, it says the probability that they like tea. So we've got a few of the numbers here that we can actually consider. We've got the 4, the 5, the 19 and the 16. So the amount of people that like tea, if we add them all together, 5 plus 4 is 9, plus the 19 is 28, plus the 16, what does that give us? 19 plus 16 plus 5 plus 4 gives us a total of 44 people that like tea. So there's 44 people that like tea out of a total of 50 people, so it's 44 out of 50. 44 of those 50 people like tea, and the rest don't like tea. You've got the 1 person that only likes milk, you've got the 2 people that like milk and coffee, and the 3 people that only like coffee. So 44 over 50, and you don't need to simplify that. And that's our Venn diagram done. Just make sure you go through and tick them all off as you go so you haven't missed any. Let's have a look at another one of these. Okay, and on some probability here, it says there are 5 red pens, 3 blue pens and 2 green pens in a box. Leah takes at random a pen from the box and gives the pen to a friend. Leah then takes at random another pen from the box, work out the probability that both pens are the same colour. So we can do this using a probability tree, but there are 3 things. So I'm going to have 3 branches here, and it can get quite messy. So we've got red, we've got blue, and we've got green. Now in total there we've got 5 red pens, 3 blue pens and 2 green pens, and in total that adds up to 10 pens. So this is going to be all out of 10 pens here. So the probability of getting a red is 5 out of 10. The probability of getting a blue is 3 out of 10. And the probability of getting a green is 2 out of 10. Now it's up to you, we can do all 3 branches coming off these if you want for that second pick. It says she doesn't replace it, so off each branch you've got red, blue, green, red, blue, green, and red, blue, green for the bottom. But really, we're only really concerned here about the same colour, so I want to know what's the probability of red on the second pick if we take a red, what's the probability of blue here if we take a blue, and what's the probability of green down here if we take a green. Now if we think about this, there are 5 red pens in the box, so if we were to take another red pen that would reduce down to 4, so there would only be 4 red pens left, and now there'd only be 9 in the box. So I don't need to fill in every branch on the tree here. We've still got 3 out of 9 for blue, and we'd still have 2 out of 9 there for green, but I only really care about the probability of getting another red at this point. Moving on to the blue branch, so down here, we have 3 blue pens in the box, so if we take one out, we've now only got 2 blue pens, and again, that's going to be out of 9. So that's the probability of getting a blue if we took a blue on the first pick. And then the final scenario down here, if we took a green on the first pick, we'd only have 1 green left. And again, there'd only be 9 in the box, so that'd be 1 out of 9. So there's the probability of getting this second colour when it's the same. So just like normal probability trees, we just need to work out these 3 probabilities here. So for the first one, we'd do 5 over 10 multiplied by 4 over 9, which is nice and easy for us to do, times the top is 20, times the bottom's 90. Into the middle, we've got 3 over 10 multiplied by 2 over 9, and again that's going to be over 90, but with 3 times 2 on the top, which is 6, and 90 on the bottom again. And then the final one, we've got 2 over 10 multiplied by 1 over 9, and 1 times 2 is 2, and again 90 on the bottom. So there's our 3 probabilities. We've got the probability of getting red, red of 20 over 90, blue, blue would be 6 over 90, and green, green would be 2 over 90. So when we want to combine all of these together, all we have to do is add them all up. So add all of these together to get our total probability. Let's just put some plus signs here. And 20 on the top, plus 6 is 26, plus 2 is 28. So our final probability there would be 28 out of 90. And again, you don't need to simplify that. So that'd be your final probability. There you go, a little bit of a trick there. When you are constructing these trees, if you only need certain branches, then you can just kind of ignore the others, but just be very careful what the question's asking for, because it could have asked us for different colours there. Just on a side note, if it did ask us for different colours, that would have obviously been the other 6 branches, but you can also save your time just working out the 3 that we don't need, and then we could take that numerator there, 28, away from 90. So the probability of different colours would be 62 over 90. What's left over there, different colours. Okay, that would be only though if it said different colours, and this particular question did say the same colours, so just be careful, but you could save yourself a bit of time. Rather than working out all 6, you could just work out these 3 and take it away from 90 for your numerator. Okay, that is the end of this video. Well done for making it through. Hopefully that gave you a good overview of loads of the topics that haven't yet appeared on paper 1 and 2. Of course, like I said at the start, some of these topics could still appear that have been crossed out, although they are less likely. So do make sure that you complete your revision by making sure you check over any of those topics as well, but obviously prioritising the ones that haven't yet appeared and making sure that you're happy with all of those. Now, if this is the last video that you're going to be with me for, I do wish you the best of luck in your exam. But don't forget, the day before I will be doing a revise along with me video where you can check out some common paper 3 topics and common questions that appear on paper 3 exams. So there we go, hopefully I will see you for that one, but I do wish you the best of luck on your exam. Don't forget to drop me a comment and let me know how you do on results day, and hopefully I'll see you for the next one.